Imagine for a moment that you are not just looking at the Great Pyramid of Giza, but truly seeing it. You are not a tourist snapping a photo. You are a detective at a crime scene. And the crime is the greatest heist in history, the theft of an entire civilization's deepest knowledge. The suspects are time and forgetting. The evidence is all around you, carved into millions of limestone blocks. What if every stone, every angle, every seemingly arbitrary measurement is not arbitrary at all, but a deliberate word in a silent language, a line in a hidden blueprint that stretches across continents and centuries? What if this pyramid and monuments like it scattered around the globe are all pages from the same lost instruction manual, written not in ink, but in geometry? This is the profound mystery that calls to us from the dust of ages, a puzzle encoded in the very bones of our world. Today, we are answering that call. This video is our expedition into the unknown, a journey of mapping the hidden geometry behind ancient world megastructures. We are about to pull back the curtain on a reality far more intricate and intentional than our history books often convey. We will travel beyond the weathered surfaces and the grand facades to decode the mathematical fingerprints left by master architects who thought in cycles of stars and ratios of sacred numbers. We will discover how principles of celestial alignment, where temples become frozen snapshots of the solstice sun, and sacred geometry, where the very shapes of creation were woven into floor plans and doorways, formed the invisible backbone of their most awe-inspiring achievements. This is not merely about old buildings, it is about uncovering a lost science, a sophisticated understanding of our world and our place in the cosmos that challenges the conventional timeline of human ingenuity. From the soaring peaks of Egyptian pyramids to the labyrinthine jungles of Cambodian temples, from the windswept plains of Stonehenge to the mountaintop citadels of the Andes, a common thread emerges, one of breathtaking precision and purposeful design. So prepare yourself to see the ancient world with entirely new eyes. Forget what you think you know about primitive tools and simple societies. We are embarking on a map-making journey of the mind, tracing lines of connection that defy simple explanation. We will ask difficult questions, weigh compelling evidence, and stand in awe of accomplishments that seem to whisper of a deeper, shared understanding. This is more than an archaeological tour. It is a detective story spanning millennia, and you are an essential part of the investigation. The clues are waiting, etched in stone and aligned with the heavens. All we have to do is learn how to read them. Let us begin our map. To understand the mind of an ancient architect, we must first learn their alphabet. This was not an alphabet of letters but of shapes, a visual vocabulary drawn not from human language but from the very fabric of nature and the cosmos. Picture a simple, profound shape, the first step in this geometric language. Take two identical circles and overlap them so that the center of each lies on the other's circumference. In the space where they intersect, you get a shape like an almond or the pupil of an eye. This is the vesica piscis. You can find it in the soaring stained glass windows of Gothic cathedrals like Chartres, a literal window of divine light framed by this sacred form. But centuries earlier, you would have found it etched into temple floors and sacred spaces across the ancient world. This was not chosen because it was merely pretty. To the master builders, this shape was considered a generative seed, a geometric womb from which all other perfect forms, like the triangle, the square, and the pentagon, could be born. It was the first statement in a universal declaration, a belief that creation itself followed a geometric blueprint. This belief system is what we call sacred geometry. Think of it not as a style of art, but as the ancient world's fundamental operating system. Before the first stone was ever quarried, this was the software that ran in the minds of the planners. At its heart are specific, recurring mathematical relationships, ratios and sequences that appear with uncanny frequency in the natural world. The most famous of these is the golden ratio, often called phi, approximately 1.618. This is not a random number. You can find it in the spiral of a nautilus shell, in the arrangement of leaves around a stem for maximum sunlight, and in the proportions of our own bodies, from the length of our fingers to the layout of our facial features. Then there is the Fibonacci sequence, a series of numbers where each is the sum of the two before it, beginning 0, 1, 1, 2, 3, 5, 8, and so on. As the sequence grows, the ratio between successive numbers gets closer and closer to phi. This pattern governs the branching of trees and the seed head of a sunflower. The ancients observed these patterns and came to a staggering conclusion that the universe was not chaotic but ordered, and that this order was mathematical. Philosophers like Plato, in his work Timaeus, took this idea to its logical extreme. He proposed that the cosmos was literally constructed from 5 perfect three-dimensional shapes, which we now call the Platonic solids, the tetrahedron, cube, octahedron, dodecahedron, and icosahedron. He associated these with the fundamental elements fire, earth, air, the cosmos, and water. For Plato and the traditions he drew from, these geometric forms were not metaphors. They were understood to be the actual building blocks of physical reality, the immutable templates behind the fleeting world of appearances. This was a revolutionary way of seeing. It meant that by using these same shapes and ratios in their constructions, humans could create microcosms, small reflections of the grand cosmic order. A temple built with these principles was not just a building, it was a slice of perfected reality, a pocket of harmony on earth. But this leads us to a crucial point. Sacred geometry was far more than symbolic decoration. It was deeply, ingeniously functional. Let's take the pentagram, the 5-pointed star, often misunderstood today. Within its lines are hidden multiple instances of the golden ratio. You find this same ratio in the growth pattern of many flowers. Now, consider a temple layout based on a pentagonal geometry. The structure was not just echoing a flower, it was, in a very real sense, tapping into a universal principle of stable, efficient growth and form. The angles derived from these shapes often provided exceptional structural integrity, distributing weight in ways that made monumental architecture possible. The symbolism and the physics were two sides of the same coin. The shape was chosen because it was sacred, and it was sacred in part because it was structurally sound, a perfect marriage of meaning and material science. This creates a fascinating possibility that sacred geometry acted as a universal language, a kind of prehistoric intellectual code. Two cultures separated by vast oceans and thousands of years, with no known contact, could independently discover that a rectangle with sides in the golden ratio is inherently pleasing to the human eye, or that a circle perfectly represents cyclical time and celestial motion. They would then encode this discovery into their most important structures. When we see the same ratio in the floor plan of the Parthenon in Greece and in the dimensions of the Great Pyramid in Egypt, we are not necessarily looking at evidence of direct contact, though that is a tantalizing theory. We might instead be witnessing the independent discovery of a universal constant, a mathematical truth that different civilizations articulated in their own cultural dialect of stone. This geometric framework provided a consistent rulebook, allowing for a breathtaking diversity of architectural expression, from ziggurats to stupas, all while potentially playing by the same fundamental rules of cosmic harmony. It is this shared, hidden syntax that we begin to trace, starting with this first principle, the belief that to build was to participate in the geometry of creation itself. Now, if sacred geometry provided the ancient architects with their alphabet and grammar, then the movements of the sun, moon, and stars provided the narrative, the the epic story they were desperate to tell and to participate in. Let us transport ourselves to a specific moment, a single dawn on the winter solstice, over 3,000 years ago. In a temple carved deep into a rock face at a site like Newgrange in Ireland, a community waits in the inner chamber, a space of profound darkness and silence. As the sun crests the distant horizon, its first golden light does not flood the entrance. Instead, it enters through a specially constructed narrow roof box, a slit perfectly calculated. For 17 breathtaking minutes, a single, razor-thin beam of sunlight travels slowly down the long passageway, finally striking the central altar stone or illuminating intricate spiral carvings deep within the mound. This was not a happy accident of architecture. This was a meticulously engineered celestial event, a moment where heaven touched earth on a schedule written in stone. This discipline of uncovering these intentional relationships is called Archaeoastronomy, and it reveals our ancestors not as primitive stargazers, but as consummate cosmic cartographers. They were mapping time itself. In an era before printed calendars or digital reminders, the sky was the most reliable clock and calendar imaginable. The sun's journey north and south marked the solstices, the foundation of the agricultural year, telling communities when to plant and when to harvest. The moon's phases provided a shorter, rhythmic cycle, but to capture these moments in architecture required phenomenal patience and precision. Consider the sun dagger at Choco Canyon in the American Southwest. High on Fejada Butte, 3 large stone slabs lean against a cliff face. Behind them, spiral petroglyphs are carved into the rock. On the summer solstice, a dagger of sunlight slices perfectly through the center of the largest spiral. On the winter solstice, 2 daggers of light bracket it. At the equinoxes, a shaft of light bisects a smaller spiral nearby. This is a calendar etched directly into the landscape, a solar observatory of stunning elegance that required generations of observation to design and construct. It transformed an abstract celestial event into a tangible, dramatic light show, a communal confirmation that the cosmic order was proceeding as it should. This drive to monumentalize the sky took on even grander, more permanent forms. Perhaps the most famous celestial alignment on Earth is the summer solstice sunrise at Stonehenge. If you stand at the center of the stone circle and look through the entrance past the outlying heel stone, you will see the sun rise directly over that marker on the longest day of the year. The entire horseshoe arrangement of massive trilithons, those iconic 3 stone gateways, opens toward this northeastern point, framing the celestial spectacle. But Stonehenge's astronomical ambitions likely went far beyond the sun. The arrangement of its stones and its surrounding Aubrey holes may have formed a sophisticated predictive model for tracking lunar cycles and even eclipses, events that would have held immense, perhaps fearful, significance. This was not a passive temple, it was an active calculator, a Neolithic computer in stone designed to anticipate the rhythms of the cosmos. Then we have the profound and controversial correlation between the 3 great pyramids of Giza and the 3 stars of Orion's belt. The theory, popularized by researchers like Robert Bovell, notes that the layout of the pyramids on the ground mirrors the slightly offset arrangement of those stars in the sky during the Old Kingdom period. Furthermore, the southern shaft from the king's chamber in the Great Pyramid is argued to have pointed directly toward Orion's belt, associated with the god Osiris, while the northern shaft pointed toward the circumpolar stars, the so-called imperishable ones that never set, symbolizing eternal life. Whether this correlation is precise intent or compelling coincidence is hotly debated, but it exemplifies the powerful idea that these monuments were designed as a mirror, a terrestrial reflection of a specific celestial realm. The pharaoh's soul was to ascend via these star shafts to take his place among the undying lights. The geometry of the sky was literally projected onto the desert plateau, turning the entire necropolis into a permanent star map for the afterlife. Achieving these alignments across decades or even centuries of construction speaks to a staggering continuity of knowledge and purpose. It required advanced observational techniques, likely using simple but effective tools like sighting poles, horizon markers, and perhaps even filled water trenches to create perfectly level surfaces and true horizons. It demanded a deep, generational understanding of cyclical time, recognizing that celestial patterns repeat over long periods. This was a science of patience, where a single alignment might only be verifiable on one morning a year, and the full pattern of a lunar cycle might take 18.6 years to complete. The builders were playing a long game, constructing monuments that would outlive them by millennia, all to capture a moment of cosmic harmony. This celestial connection reveals a global preoccupation that transcends any single culture. From the solar alignment of the Temple of Karnak in Egypt, where the axis of the temple aligns with the midwinter sunrise, to the Mayan pyramid of El Castillo at Chichén Itzá, where the setting sun on the equinoxes creates a shadow serpent slithering down the staircase, we see the same impulse. It is the desire to harmonize human endeavor, whether it's the rule of a pharaoh, the planting of crops, or the timing of a sacred ritual with the perceived cosmic order. The megastructure becomes the anchor point, the fixed proof that humanity is in sync with the universe. It turns architecture from a shelter into a statement, a declaration that we have read the sky, we have understood its geometry, and we have built our truth into the very bones of the earth. This projection of celestial geometry onto the landscape is our second core principle, a testament to the ancient world's profound and active relationship with the cosmos, a relationship that would naturally lead them to consider an even more astonishing possibility, that the Earth itself held a geometric pattern they could discover and map. But if ancient architects were so adept at mapping the heavens above, could they have also been mapping the very earth beneath their feet with a sophistication that still eludes our full understanding? This brings us to our third, and perhaps most contentious, principle, geodetic knowledge and the enigmatic concept of ley lines. Geodesy is the science of accurately measuring and understanding the Earth's geometric shape, its orientation in space, and its gravitational field. It's what allows modern cartographers to create our precise global maps and GPS systems to function. To suggest that cultures thousands of years ago possessed even a rudimentary form of this knowledge seems, on its face, an extraordinary claim. Yet when we look at the placement of certain key monuments, the evidence becomes quietly compelling. Consider once more the Great Pyramid of Giza. Its precision is not merely in its shape, but in its location on the planet. The pyramid is oriented to the 4 cardinal directions with an accuracy within a tiny fraction of a degree, a feat that would challenge modern surveyors without advanced tools. But it goes deeper. The pyramid sits at the intersection of the longest line of latitude and the longest line of longitude that pass over land. In other words, if you look at a world map, the Great Pyramid is positioned at the very center of the Earth's landmass. Now, this could be a staggering coincidence, but the mathematical probability of such a precise central placement occurring by chance is astronomically low. It suggests the builders had a concept of their position relative to a larger whole, a sense of global geography that we simply do not credit them with. This isn't about aliens or lost super technology, but about the possibility of a painstakingly accumulated, orally transmitted body of knowledge about the Earth's dimensions, perhaps gathered over centuries by seafaring or trading cultures who tracked star positions from different coastlines and slowly pieced together a mental map of continental relationships. This idea of a hidden geographical grid leads us directly into the murky and fascinating world of ley lines. The term was popularized in the 1920s by an amateur archaeologist named Alfred Watkins, who, while looking at maps of the English countryside, had a sudden vision of straight tracks connecting ancient hill forts, mounds, old churches built on pagan sites, and prominent natural landmarks. He called these alignments lays, suggesting they were ancient trade routes or ceremonial pathways. The modern interpretation, however, has spiraled far beyond Watkins' original, practical idea. Today, ley lines are often discussed as invisible lines of earth energy, psychic highways, or a global grid of spiritual power that ancient cultures could detect and mark with their sacred sites. Mainstream archaeology and geology largely dismiss this, and for good scientific reason. There is no measurable energy field associated with these lines, and with thousands of ancient sites scattered across any landscape, drawing straight lines between some of them is a statistical certainty, a classic case of finding patterns in random data. Yet the folklore is persistent and strangely specific. Take the St. Michael Line, one of the most famous alleged ley lines in Britain. It runs in a nearly straight line from the tip of Cornwall through a series of sites dedicated to the Archangel Michael, often places where earlier pagan sun gods were worshipped, including St. Michael's Mount, Glastonbury Tor, and the Avebury Stone Circle before continuing across England. The alignment is visually striking on a map. So, what are we to make of this? One rational explanation is that prominent, spiritually significant landmarks, like conical hills or springs, were naturally chosen for veneration across different eras, and later Christian churches deliberately built on these same sites to co-opt their spiritual potency, creating an accidental alignment over time. Another possibility is that these lines represent ancient pilgrimage routes, processional ways where the journey itself, walking a straight path toward a sacred horizon, was part of the ritual. The path was the prayer. The most radical interpretation, of course, is that they are evidence of a lost surveying technology or a conscious effort to map a planetary energy grid, a concept found in various forms in Chinese feng shui with dragon lines or the Aboriginal song lines of Australia. While the energy aspect remains unproven and veers into pseudoscience, the geometric possibility is harder to dismiss outright. Could our ancestors have used simple yet profound methods of long-distance alignment? Imagine two groups miles apart, using synchronized fire beacons or reflected sunlight from polished metal plates to establish a straight sightline across a landscape, then marking that line with mounds or stones. Such a technique would require incredible coordination and a shared cultural purpose, but it is not beyond human capability. These lines would then serve multiple purposes, as territorial markers, as astronomical sightlines for calendar keeping, and as ceremonial corridors connecting communities to their sacred geography. The debate between coincidence, cultural memory, and intentional geodetic science remains fiercely unresolved. But it forces us to ask a profound question. Did ancient cultures see the landscape not just as a place to live, but as a living body to be read, a vast geometric puzzle where certain nodes and lines held meaning? Whether they were mapping trade routes, spiritual pathways, or something more enigmatic, the very persistence of the ley line idea speaks to a deep human intuition that our sacred sites are connected in ways that transcend the simple practicalities of daily life. This notion of a hidden terrestrial geometry provides the essential backdrop for our next step, where we take all these principles, sacred geometry, celestial alignment, and geodetic awareness, and apply them to the ultimate test case, the structure that stands as the greatest enigma of them all. Now, let's apply our principles to the ultimate test case, the structure that has stared down the centuries, defying simple explanation, the Great Pyramid of Khufu at Giza. We must move beyond its staggering size, the familiar statistic of millions of blocks, to appreciate its truly mind-boggling precision. This is not a rough pile of stones. It is a monument of engineering that exhibits a level of exactness that would be admirable even with modern tools. Consider its foundation. The base is nearly a perfect square, with the average difference between its longest and shortest sides being less than 0.2%. More astonishingly, its sides are aligned to the cardinal points of the compass with an error of just 3/60ths of a single degree. To put that in perspective, this is a finer alignment than that of the Meridian building at the Greenwich Observatory, constructed in the 17th century with the specific purpose of defining the prime meridian. This was achieved over 4,500 years ago without magnetic compasses, which hadn't been invented yet, and without the pole star in its current position to guide them. How did they do it? The likely method involved meticulous observations of a circumpolar star's rotations, creating a true north-south line with nothing but patience, keen eyesight, and a profound understanding of the night sky's mechanics. But the geometric encoding runs far deeper than orientation. Look at the pyramid's very shape. If you take its perimeter and divide it by twice its original height, you get a number incredibly close to pi, the mathematical constant representing the ratio of a circle's circumference to its diameter. This has led many to suggest the builders encoded pi into the pyramid's fundamental proportions. Mainstream Egyptology offers a different, yet equally brilliant explanation. They point to the ancient Egyptian sect, a measure of slope. The Great Pyramid's chosen sect of 5 palms and 2 digits, a ratio of rise over run, naturally produces a shape where this pi-like relationship emerges as a mathematical byproduct. This doesn't diminish the achievement, it reframes it. It shows the Egyptians were masters of applied geometry, using a practical building measurement that indirectly captured a profound universal constant. Whether by direct intention or brilliant consequence, the pyramid stands as a stone embodiment of a fundamental mathematical truth. The precision continues inside, in the king's chamber. This room is not a haphazard burial vault. It is a textbook example of sacred geometry in action. The chamber forms a perfect 2-to-1 rectangle, a proportion revered for its harmony. The chamber's walls are constructed from enormous granite blocks, fitted together with joints so precise that a credit card cannot be slid between them. Then there is the sarcophagus, made from a single block of granite harder than the surrounding limestone. Its exterior volume is exactly half the volume of the chamber's anteroom, and its internal volume matches the biblical Ark of the Covenant. It was cut with such exacting tolerances that modern engineers debate what tools could have achieved such work in such a hard material. Every element feels deliberately calibrated, a piece in a larger puzzle. This has given rise to some of the most fascinating alternative theories about the pyramid's purpose. Engineers like Christopher Dunn, after detailed analysis, have proposed it was not a tomb at all, but a sophisticated machine, a giant power plant harnessing geological vibrations and resonating with the Earth's frequency to produce energy, or a chemical reactor. Others, looking at its dimensions, see it as a scale model of the Northern Hemisphere. They note that if you take the pyramid's height and multiply it by 43,200, you get the polar radius of the Earth. The perimeter, similarly scaled, relates to the equatorial circumference. The mathematics are tantalizing, though hotly contested by scholars who attribute such correlations to the flexibility of numbers and selective interpretation. Regardless of which theory one leans toward, the overwhelming evidence points to one inescapable conclusion. The Great Pyramid is a data-rich monument. Each measurement, each angle, each alignment appears to be a deliberate data point in a vast, silent cosmological equation. It integrates our principles perfectly, its sacred proportions, its celestial alignment to true north and possibly to Orion's belt, and its potential geodetic knowledge of the Earth's dimensions. It stands as the prima facie case, the high watermark of ancient hidden geometry. It sets a bar so high that for a long time, Western scholars could not believe it was the product of its age, inventing tales of lost civilizations or divine intervention to explain it. But this masterpiece was not an isolated phenomenon. When we cross the Atlantic Ocean, we find another civilization, completely disconnected from Egypt, applying a similarly grand and geometric vision to an entire city, creating an urban plan that seems to map the heavens and the earth with equal ambition. Crossing the Atlantic Ocean, we find a testament to geometric ambition that matches the pyramids in scale and mystery, yet speaks in a completely different architectural language. This is Teotihuacan, the city of the gods, located in a highland valley north of modern-day Mexico City. Its most striking feature is the Avenue of the Dead, a vast ceremonial causeway running for nearly 2.5 kilometers, flanked by the ruins of monumental platforms. Standing at one end, looking down this grand axis toward the massive Pyramid of the Moon, you are not just in an ancient city, you are walking a carefully calibrated ritual landscape, a three-dimensional diagram where every structure is in precise geometric conversation with every other. The genius of Teotihuacan lies in its urban planning on a colossal scale. Unlike Giza, which is a necropolis of distinct, separate tombs, Teotihuacan is an integrated metropolis, a single geometric organism. The layout of its three primary monuments, the Pyramid of the Sun, the Pyramid of the Moon, and the Temple of the Feathered Serpent, also called Quetzalcoatl, forms a sophisticated triangle on the ground. Researchers, using modern surveying techniques, have discovered that the distances between these structures are not random. Intriguingly, some of these distances appear to reflect ratios that correspond to the orbital periods of planets in our solar system. For instance, the distance from the Pyramid of the Sun to the Temple of Quetzalcoatl relative to the distance from the Sun to the Moon Pyramid may mirror the ratio between the orbital periods of Earth and Venus. While these interpretations are debated, the sheer mathematical consistency of the site's measurements suggests these relationships are far from accidental. The builders seem to have projected a model of cosmic harmony onto the very ground of their city. This cosmic intent is further emphasized by the city's puzzling orientation. Unlike the Great Pyramid's near-perfect alignment to true north, the entire grid of Teotihuacan is rotated 15.5 degrees east of north. Why? This was a deliberate and challenging choice, requiring significant extra effort to maintain over such a vast area. One compelling theory points to astronomy. This specific angle aligns with the setting point of the Pleiades star cluster on a key date in the Mesoamerican calendar, a cluster deeply significant in their mythology. Another, more terrestrial theory suggests the alignment is directed toward the sacred Cerro Gordo mountain, a major source of water and a deity in its own right. This creates a powerful synthesis. The city is oriented to a celestial event in the heavens while simultaneously pointing toward a life-giving mountain on the earth, perfectly embodying the convergence of the cosmic and the geographic. The Pyramid of the Sun itself is a geometric marvel. Its base is almost exactly as wide as the Great Pyramids, yet its construction method and internal composition are entirely different. Its core is a natural hill sculpted and faced with stone, demonstrating a principle of harmonizing with the existing landscape rather than conquering it entirely. The proportions of its stepped sides, the ratios of its tiers, all follow a strict repeating module, a standard unit of measure that was used consistently throughout the city's construction. This modularity speaks to a highly organized society with master planners who could execute a complex design over generations. When we place the blueprints of Teotihuacan beside those of Giza, a fascinating pattern emerges. We do not see evidence of copying. The architectural styles, construction techniques, and cultural contexts are worlds apart. What we see instead is a parallel application of fundamental principles. Both civilizations, separated by an ocean and millennia, chose to express their highest ideals through monumental geometry aligned with celestial bodies. Both encoded mathematical ratios into their most sacred structures. Both created landscapes that served as permanent interfaces between their people and the perceived order of the cosmos. This parallel development presents us with a profound historical puzzle. Was there some lost thread of knowledge that connected these worlds, a shared inspiration from a time beyond memory? Or does this point to something inherent in the human mind, an independent discovery of a universal design code that emerges whenever a culture reaches a certain peak of spiritual and intellectual sophistication? Teotihuacan stands as a powerful argument that the language of sacred geometry is not the property of any one culture, but a native tongue of human aspiration, waiting to be rediscovered and spoken in stone, whether on the sands of Egypt or in the high valleys of Mexico. And this conversation between geometry and the natural world reaches its most dramatic expression high in the cloud forests of another continent, where an entire city was not just placed upon a mountain, but was woven into its very bones. While Teotihuacan demonstrates geometry imposed upon a grand plain, our journey now takes us to a place where geometry had to yield, adapt, and ultimately collaborate with a far more dominant partner, the living mountain itself. High in the Peruvian Andes, clinging to a saddle between two jagged peaks, sits Machu Picchu. This is not a city of rigid grids or perfect cardinal alignments. Instead, it is the ultimate expression of a different kind of hidden geometry, one of adaptive angles and sacred integration. Here, the architecture does not conquer the landscape, it enters into a profound, dynamic conversation with it. The geometry is not about asserting human order over nature, but about discovering and amplifying the inherent order already present in the stone, the slopes, and the sky. The most immediate clue to this adaptive philosophy is in the very shape of the openings. Walk through the ruins and you will see them everywhere: trapezoidal doors, windows, and niches. This distinctive shape is far more than an aesthetic choice. Structurally, the trapezoid is a masterpiece of ancient engineering. The wider base and inward sloping sides provide exceptional stability against the constant seismic tremors that ripple through the Andes. But the geometry of these shapes also creates specific, intentional angular relationships. The angles are not random, they are consistent, suggesting the use of standardized templates or a deeply understood building code. These angles may have been derived from astronomical observations, perhaps mirroring the angle of the sun's rays at significant times of the year, or they could create specific framed views of sacred peaks, known as pews, turning each doorway into a living painting of the divine landscape. At the heart of this celestial dialogue stands the Teotihuacan stone, often called the hitching post of the sun. This elegantly carved granite pillar is the citadel's crowning astronomical instrument. It is not a simple marker, it is a sophisticated, multi-angled sundial and calendar. Its carefully sculpted angles and planes are precisely cut so that the shadow it casts falls in a specific, meaningful way. On the equinoxes, the sun is positioned directly above the pillar, causing its shadow to vanish entirely, a dramatic symbol of the sun being hitched to the earth. During the solstices, the shadow points to distinct, marked locations, allowing the Inca priests to track the sun's journey with remarkable accuracy. This single stone transforms the entire plaza into a timekeeping device, proving that their geometry was kinetic, interacting with the moving light to mark the passage of sacred time. The orientation of the entire citadel further reveals this deep intentionality. The main structures and the central plaza are not aligned to magnetic north. Instead, they are carefully positioned relative to the surrounding sacred geography and solar pathways. The layout seems designed to capture the first and last rays of the sun on pivotal days, illuminating specific temples or stairways. Some researchers propose that alignments between certain structures point directly to the rising or setting positions of important stars or constellations during key festivals. This turns Machu Picchu into a three-dimensional observatory, where the architecture itself forms the sighting tools. and the majestic backdrop of Picchu and Machu Picchu mountains become the fixed points of this colossal natural compass. What Machu Picchu teaches us is a vital expansion of our map of hidden geometry. It shows us that this ancient science was not monolithic. It was not always about imposing perfect circles and squares from a celestial blueprint onto a passive Earth. Here, geometry becomes responsive, even humble. It is the art of listening to the mountain and finding the angles, the planes, and the orientations that would resonate with its form. The builders used geometry as a translator, a means to harmonize human aspiration with the immutable contours of the natural world. This is the principle of sacred geography, where a site is chosen not just for its defensibility or resources, but for its energetic or spiritual congruence with the cosmos. The geometry then becomes the tool to enhance that connection, to weave the built environment so seamlessly into the natural one that it becomes impossible to tell where the mountain ends and the temple begins. This represents a pinnacle of design thinking, where the hidden code is not a rigid formula, but a flexible language of integration, speaking of a civilization that saw itself not as separate from nature, but as a conscious, grateful part of its eternal geometry. From the living mountains of Peru, we travel now to the windswept Salisbury Plain in England, to a monument that has defined mystery for millennia, Stonehenge. We have all seen its iconic silhouette, those massive sarsen stones capped with lintels standing in lonely defiance against time. For generations, it was popularly imagined as a druid temple, a place of ancient ritual. But what if we have been fundamentally misunderstanding its purpose? Modern research is revealing a far more technically ambitious vision. Stonehenge is increasingly seen not as a static temple, but as a dynamic, sophisticated machine built from stone, a Neolithic calculator engineered to track the complex rhythms of the cosmos with astonishing precision. The first clue to this function is in its most famous alignment, the avenue that points toward the sunrise on the summer solstice. But to focus only on that is to see just one note in a grand symphony. The entire arrangement of stones is a dense web of geometric and astronomical relationships. Consider the site's layout. At its heart is a horseshoe of 5 massive trilithons, those iconic 3 stone gateways. Surrounding them is a circle of sarsen stones, all originally connected by a continuous ring of lintels, creating a perfect raised stone circle. Earlier, there were the smaller blue stones arranged in their own concentric patterns. This architecture of nested circles and a central horseshoe is not random. It creates a series of precise viewpoints and sightlines. Astonishingly, embedded within this stone circle are shapes that would not be formally described for thousands of years. Researchers, most notably the engineer Alexander Thom, have meticulously surveyed the site and found that the positions of key stones form perfect Pythagorean triangles. These are right-angled triangles whose sides are in whole number ratios like 3, 4, 5. The use of such a triangle guarantees a perfect right angle, a fundamental tool for construction and alignment. The so-called station stones, 4 stones that sit just outside the main circle, form a near-perfect rectangle. The diagonals of this rectangle, when extended, point to significant sunrise and sunset points on the horizon for both the summer and winter solstices. This isn't just one alignment, it's an integrated geometric framework that captures multiple celestial events. But the true genius of Stonehenge as a calculator may lie in what you can no longer see in the empty spaces. Circling the entire monument is a ring of 56 pits known as the Aubrey Holes, named after their 17th century discoverer. The number 56 is not arbitrary. It holds a powerful key to predicting lunar eclipses. The moon's cycles are complex, but one of the patterns ancient astronomers likely observed is the Saros cycle, a period of approximately 18 years and 11 days after which eclipses repeat. However, a more manageable, shorter cycle for tracking lunar phases and eclipse danger periods involves multiples of the number 19 and the number 56. The theory proposed by astronomer Gerald Hawkins suggests that by moving marker stones around this circle of 56 pits, one per year, the keepers of Stonehenge could have tracked the years and predicted when a lunar eclipse was likely to occur. Imagine the power this knowledge held to seemingly command the heavens, to know when the moon would turn an ominous red, and to prepare the community for this awe-inspiring event. This transforms our view of the monument entirely. The concentric circles become calibrated sighting rings. The horseshoe of trilithons creates a framed window for observations. The station stones and hidden triangles form a permanent back-sight for alignments, and the Aubrey holes become a functional, movable counting mechanism. This was not merely a place to worship the sun and moon. It was a place to understand them, to measure their movements, and to predict their most dramatic behaviors. It was an institution of learning and timekeeping, a celestial observatory built for the ages. The geometry of Stonehenge, therefore, is not decorative symbolism. It is the essential hardware of a lost software, the physical expression of a deep, accumulated knowledge of cyclical time. In its silent stones, we find the evidence of a society that looked to the sky not just with wonder, but with a determined, analytical mind, encoding the mathematics of the heavens into a timeless, earth-bound calculator. From the stark, geometric plains of Salisbury, we are transported to the lush, humid jungles of Southeast Asia, to a complex so vast it forms its own sacred landscape. Angkor Wat, at first glance it seems the polar opposite of Stonehenge, a sprawling temple city of intricate carvings, soaring towers, and vast moats. Yet here we encounter hidden geometry of a different order, one where mathematics is inseparable from mythology, and the entire site becomes a breathtakingly precise model of the cosmos itself. This is not merely a temple, it is a celestial mandala carved in stone, a coded map of Hindu universe theory brought to life on an unimaginable scale. To understand its geometry, you must first understand its purpose. Angkor Wat was conceived as a physical representation of Mount Meru, the mythical mountain at the center of the universe in Hindu and Buddhist cosmology. This is the axis mundi, the pole around which all creation revolves. The architecture makes this metaphor stunningly literal. The central, tallest tower is Mount Meru's peak. The four slightly smaller towers surrounding it are the mountain's lesser peaks. The concentric rectangular galleries and courtyards represent the mountain ranges that ring Meru, and the massive moat encircling the entire complex symbolizes the cosmic ocean at the edge of the world. Simply by walking from the outer wall toward the central sanctuary, a pilgrim symbolically journeys from the periphery of reality toward its divine, central source. This entire spiritual journey is mapped through precise, nested rectangles and radial axes. The dimensions of this map are not arbitrary, they are a numerical scripture. Researchers have found that the key measurements of Angkor Wat encode the sacred chronology of Hindu time, the great cycles known as yugas. These are immense spans, like the Kali Yuga of 432,000 years. Astonishingly, the total length of the temple's central axis, or the perimeter of certain galleries, corresponds to ratios of these numbers. The layout acts as a permanent, physical calendar for cosmic time, embedding the very rhythm of creation and dissolution into the distance between its walls. It is a form of architectural cryptography, where to know the sacred numbers is to read the building's deepest meaning. But the most jaw-dropping geometric revelation involves not just myth but the night sky. In the 1990s, a researcher named John Grigsby made a startling proposal. He suggested that the principal temples of the greater Angkor complex, not just Angkor Wat but sites like Angkor Thom and Precon, were not placed randomly across the landscape. Instead, he argued, their relative positions on the ground mirrored the stars of the constellation Draco, the dragon, as they would have appeared in the sky above Angkor at the spring equinox in the year 1150, right at the height of the empire's construction. When you plot the temples on a map and overlay the stars of Draco, the correlation is visually striking. Angkor Wat itself aligns with the star Beta Draconis. This suggests a deliberate act of terrestrial astronomy on a colossal scale, turning hundreds of square miles of jungle into a mirror of the heavens. Consider the implication. The builders first designed Angkor Wat as a model of the metaphysical universe, Mount Meru and its surrounding cosmos. Then, in a staggering act of ambition, they placed that model within a larger, regional pattern that reflected the actual, physical night sky. The geometry thus operates on two simultaneous, interconnected levels. On the micro scale, the temple's perfect proportions and symbolic ratios map a philosophical and spiritual reality. On the macro scale, the sprawling urban plan maps an astronomical reality. It is a duality of sacred geometry, one inward and symbolic, the other outward and celestial, fused into a single grand vision. This fusion of math, myth, and astronomy makes Angkor Wat one of the most sophisticated examples of hidden geometry in the ancient world. The geometry is not hidden in secret chambers or subtle angles. It is the entire, glorious, overwhelming point. Every wall, every tower, every measurement is a word in a stone language describing humanity's place in the cosmos. It demonstrates that for these architects, to build was to perform a cosmic duty, to recreate on Earth a perfect, harmonic echo of divine order, ensuring the kingdom's alignment with the forces that govern both the stars and the soul. In the shadow of its towers, we see geometry not as a cold science, but as a living, breathing act of cosmic poetry. From the mythic, star-aligned mandalas of Angkor, we make a profound shift in philosophy and purpose, traveling westward to the heart of an empire built not on cosmic speculation, but on sheer, unyielding will. The Romans, their geometry whispers a different secret. It is not a language for speaking to gods, but a toolkit for ruling the world. In the Roman mind, geometry was the ultimate expression of practical power, a discipline deployed to impose order on chaos, to project control across thousands of miles, and to showcase a technological prowess that left conquered peoples in awe. This is hidden geometry stripped of its celestial mystery, yet amplified in its terrestrial impact, becoming the very skeleton upon which the modern Western world was built. Consider the Roman city, the ultimate geometric statement. Where earlier cultures might orient a temple to a solstice sunrise, the Romans began with two simple, powerful lines scratched into the earth. The Cardo, a north-south road, and the Decumanus, an east-west road. They crossed at a perfect right angle at the city's center, the Forum. From this intersection, a rigid grid of streets was surveyed, dividing the land into uniform blocks called insulae. This was not sacred urban planning, it was a military and administrative blueprint. A soldier, a tax collector, or a merchant arriving in any Roman town from Britannia to Syria would instantly know their way around. The grid imposed a predictable, controllable order. It facilitated the movement of troops, the management of populations, and the efficient flow of goods and information. This geometric rigidity was a physical manifestation of the Roman ideal of disciplina, a system so effective and replicable it became the foundational model for cities across Europe and beyond, echoing even in the street plans of modern metropolises. This mastery of applied geometry extended far beyond city limits into the very landscape itself. The Roman aqueduct stands as perhaps the purest expression of this. To bring water from a distant spring to a thirsty city required a gradient so precise, so consistent, that it would drop only a few inches every 100 feet over dozens of miles. Surveyors, using simple but brilliantly effective tools like the groma for alignment and the chorobates, a water level, plotted these courses through valleys and across plains. They calculated the arcs of towering stone bridges that carried water channels high above rivers, arcs that were segments of perfect circles, distributing weight with mathematical elegance. The aqueduct was not a monument to a deity. It was a monument to human ingenuity and imperial benevolence, a geometric lifeline that declared, "We command nature itself to serve our cities." Nowhere is the Roman synthesis of practical engineering and profound geometric vision more breathtakingly realized than in the Pantheon in Rome. From the outside, it is a formidable classical temple front. But step inside and you enter a different realm of spatial genius. The interior is a perfect sphere, 150 Roman feet in diameter, nestled precisely within a cylinder of equal height. The dome, with its famous oculus open to the sky, is a hemisphere of cast concrete, its thickness carefully graduated and its interior coffered in a pattern that reduces weight while creating a mesmerizing geometric cascade. The building is a single, unified geometric theorem in stone and space. Every measurement relates. The distance from the floor to the oculus is exactly the radius of the sphere, meaning if you completed the sphere downward, it would just kiss the center of the floor. This was not a random design. It was a conscious embodiment of the Roman worldview, a microcosm where the dome represented the vault of the heavens and the cylindrical base the solid, ordered earth. It was geometry as imperial cosmology, demonstrating that even their most practical minds understood the symbolic power of perfect form. Crucial to this empire-wide geometric consistency was a simple yet revolutionary tool: standardization. The Roman foot, approximately 11.6 modern inches, was not a vague approximation. It was an official, standardized unit, meticulously defined and replicated across the empire. Military engineers, architects, and land surveyors all used the same measure. A blueprint for a fortress gate in Germany could be sent to North Africa, and using the same standard foot, the local builders could construct an identical gate. This geometric lingua franca allowed for the mass production of empire. Standardized bricks, standardized pipes, standardized dimensions for barracks and baths, all flowed from this commitment to a universal measure. It turned geometry from a local art into a scalable system of control, enabling the Romans to imprint their identity on a continental scale with a consistency no ancient civilization had ever achieved. So, while the pyramids and Stonehenge seem to ask us to look upward, Roman geometry asks us to look outward across the conquered earth. Their hidden geometry is not encrypted in star alignments or sacred ratios, though they understood those too. It is encoded in the relentless straight line of a road, the unwavering arc of an aqueduct, the perfect sphere of a dome. It is geometry in the service of imperium, order, control, efficiency, and the awe-inspiring demonstration of a power so advanced it could shape the world to its will. In their hands, geometry became the visible architecture of dominion, a testament to the fact that the most enduring form of power is often the one that builds the most perfect and most practical of lines. But after witnessing the Roman grid, a question that has been simmering beneath the surface of our entire journey now demands to be asked. We have mapped a stunning web of geometric principles stretching from the deserts of Egypt to the jungles of Cambodia, from the high Andes to the plains of England. How is this possible when faced with such widespread, sophisticated parallels? The mind instinctively seeks a source, a single point of origin. This brings us to the greatest historical mystery in our investigation, the enigma of the builders themselves. Did this knowledge travel the ancient world, passed from one master culture to another, or did it spring up independently, like a universal idea whose time had come in multiple places at once? One compelling explanation is the diffusionist theory. This idea suggests that the core principles of sacred geometry, advanced astronomy, and precise engineering were developed by one profoundly advanced and now lost precursor civilization. Perhaps it was the legendary Atlantis, or a sophisticated culture from the last ice age whose traces were erased by rising seas. Proponents of this view point to the most tantalizing clue, the pyramid. Consider the form, a structure with a square base and 4 triangular sides meeting at a point. We find it not just in Egypt, but in Mesopotamia, in Mesoamerica at Teotihuacan and Chichén Itzá, in the stepped pyramids of ancient China, and in the temple mounds of North America. The diffusionist asks, is it really plausible that cultures separated by vast oceans and millennia all independently arrived at this specific, complex architectural solution? They argue that the similarities go beyond mere shape, pointing to shared elements like internal chambers, precise orientations, and incorporation of pi and phi. The theory proposes that seafaring explorers, survivors of a great cataclysm, or a dedicated caste of priest architects traveled the globe, seeding this advanced knowledge wherever they went, acting as the wise teachers who kick-started civilization. Standing firmly against this is the theory of independent invention. This school of thought, favored by much of mainstream archaeology, argues that humanity possesses a shared cognitive toolkit. When societies reach a certain threshold of complexity with stable agriculture, social hierarchy, and a need to express power and cosmology in monumental form, they inevitably discover the same fundamental principles. The pyramid, in this view, is not a copied blueprint but a logical conclusion. It is the most stable way to build tall with stone, a shape that naturally arises when you stack material upward while maintaining stability. The alignment with celestial bodies is a global human preoccupation, born from the universal need to track seasons for survival. The discovery of the golden ratio or harmonic proportions, cognitive archaeologists suggest, may be wired into our very perception. Our brains are naturally drawn to certain balances and patterns that we see reflected in nature, from the spiral of a shell to the branching of a tree, so it is no surprise that these patterns emerge independently in our art and architecture. In this light, the parallels are not evidence of contact but proof of a shared human genius, a convergent intellectual evolution where great minds, facing similar challenges under the same sky, simply think alike. Perhaps the most satisfying answer lies not in choosing one theory over the other, but in a nuanced blend of both. Could there have been limited, sporadic contact that sparked ideas, which were then developed independently to glorious, unique conclusions? The Olmecs of Mexico, for instance, developed a sophisticated calendar and monumental sculpture without, as far as we know, any contact with the Old World. That suggests powerful, independent invention. Yet, the sudden and nearly simultaneous rise of pyramid construction in Egypt and the Americas during a relatively narrow window of ancient history is a coincidence that continues to intrigue and baffle scholars. It is the ultimate historical detective story, with clues etched in stone across the planet. We must weigh the evidence without dogma, acknowledging that our current understanding of ancient sea travel and cultural exchange is incomplete. Every new archaeological discovery, from a sunken ship to an underwater settlement, has the potential to redraw the maps of the ancient world and the connections between its people. This mystery of transmission versus genesis is not just an academic debate. It strikes at the heart of how we view human history. Is it a story of a single, golden source of wisdom now forgotten, or a triumphant narrative of multiple cradles of innovation? Either answer is profound. The first suggests a forgotten chapter of global unity and advanced knowledge. The second celebrates the incredible, recurring capacity of the human mind to decode the universe. As we continue our map, this question will linger, a silent partner to every geometric ratio and celestial alignment we uncover, reminding us that we are not just measuring stones, but attempting to measure the very nature of human ingenuity itself. So we are left with a profound appreciation for the structures themselves, but also a very practical puzzle. We have established the what, the incredible precision and encoded geometry. Now we must confront the how. It is tempting, when faced with such perfection, to leap to extraordinary explanations, to invoke lost super science or otherworldly guidance. But the most satisfying, and indeed the most respectful, answer lies not in diminishing human capability, but in truly appreciating it. Let us step onto the construction site, so to speak, and examine the toolbox. The truth is, the ancient world was filled with brilliant, pragmatic engineers whose tools, while simple in principle, were wielded with a mastery that could achieve breathtaking results. For laying out the very foundations of their world, they employed elegant devices based on basic physics. Take the humble yet revolutionary groma. Imagine a vertical staff with a horizontal crosspiece from which plumb bobs were suspended on strings. By sighting along these perfectly vertical lines, a Roman surveyor or an Egyptian before him could establish perfectly straight lines and, more importantly, perfect right angles across vast distances. This simple tool, essentially a precursor to the modern theodolite, is what laid out the relentless grids of Roman cities and likely ensured the near-perfect squareness of pyramid bases. For establishing a level plane, they turned to water, a water level which could be as simple as a length of hollow reed or a carved trench, uses the immutable fact that water seeks its own level. By connecting a series of these levels, builders could transfer a horizontal reference line over long, uneven ground, ensuring that the first course of stones for a temple platform or an aqueduct was perfectly flat, a critical first step for everything that followed. When their gaze turned from earth to sky, their tools became exercises in focused observation. For tracking the slow drift of stars or pinpointing a solstice sunrise, they likely used sighting tubes. These were long, narrow tubes, perhaps made of wood or reed, that eliminated peripheral light and allowed a priest astronomer to pinpoint a specific star on the horizon with remarkable accuracy. The famous Mayan observatory at Chichén Itzá, El Caracol, with its narrow, strategically placed windows, functions on this very principle. It turns a building into a giant, permanent sighting device. And we must never underestimate the power of the shadow. A simple vertical gnomon, a rod stuck in the ground, becomes a powerful solar instrument. By meticulously marking the tip of its shadow throughout the day and across the year, one can map the sun's path, determine true north and south, and mark the solstices and equinoxes with precision. The entire science of archaeoastronomy rests on the intelligent use of such basic, yet profoundly effective, tools, but were they limited to sticks and shadows? The discovery of the Antikythera mechanism, a corroded bronze artifact recovered from a Greek shipwreck, shattered our assumptions about ancient technological ceilings. This intricate device, dating to around the 2nd century before the Common Era, is a complex assembly of precisely cut bronze gears. It was, in essence, a mechanical computer capable of predicting lunar phases, solar eclipses, and the positions of planets. It proves conclusively that the Greeks, and likely other cultures, possessed a sophisticated understanding of gearing and cyclic astronomy that could be translated into a physical machine. This one artifact opens a door, suggesting that the conceptual leap from a sighting tube to a geared calendar or an alignment calculator was not only possible but had actually been made. This leads to other tantalizing possibilities. Could they have used lenses? While no definitive ancient lenses for astronomical observation have been universally accepted, there are artifacts like the Nimrod lens from Assyria, a piece of rock crystal ground into a vaguely oval shape that could concentrate sunlight. Whether it was a magnifier, a burning glass, or a decorative piece is debated, but its existence shows the manipulation of light was within their realm of experimentation. Polished metal mirrors made of copper or bronze could have been used not just for reflection, but for signaling or even creating controlled beams of light for interior temple alignments on specific days. The key insight here is not that they had laser rangefinders, but that they understood the properties of light and reflection well enough to harness them for their purposes. Ultimately, the greatest tool in their arsenal was not made of bronze or wood, but of flesh and mind, patience and cumulative knowledge. We are talking about generations of dedicated observers who tracked celestial cycles for centuries, recording their data on clay tablets or in oral traditions. We are talking about master craftsmen who understood the properties of their materials intimately, who could dress a stone so precisely that a knife blade could not fit between the joints. This was a culture of iteration and refinement, where techniques were honed over lifetimes and passed down through guilds or priestly castes. The precision we marvel at is the product of this immense human capital, of keen eyesight, steady hands, and a profound willingness to invest time on a scale that feels alien to our fast-paced world. They did not need magic, they had methodology. They did not need super technology, they had supreme skill. And in grounding their accomplishments in this tangible human ingenuity, we do not diminish the mystery, we deepen it. For it reveals that the true wonder is not in how they built these marvels with so little, but in what they chose to build with it, encoding not just stability, but the very order of the cosmos into the quiet, enduring language of stone. Yet this mastery of measurement and alignment points toward a deeper, more profound purpose. If we view these structures only as feats of engineering or astronomical calculators, we miss their very heart. For the ancient mind, the line between the practical and the spiritual, the mathematical and the mystical, did not exist. Geometry was the visible language of the invisible world, a bridge built not of stone, but of symbol, connecting the human realm to the divine. To understand this is to move from simply decoding their blueprints to hearing their whispers. Consider the most fundamental shapes. The circle, with no beginning and no end, perfectly represented eternity, the cycles of the heavens, and the divine essence that encompassed all things. Its opposite, the square, with its 4 equal sides, was a symbol of the earth, of stability, materiality, and the 4 cardinal directions. When a builder combined these shapes, they were doing something far more significant than solving a design problem. They were enacting a cosmic principle. This is why the pyramid form is so powerful and appears across cultures. It is not merely a stable way to pile stones high. It begins as a square, anchored firmly in the earthly plane, and ascends through triangular faces to a single point, an apex reaching for the sky. It is a machine for transformation, a physical metaphor for the soul's journey from the material world toward the celestial. Each stone laid was part of this mediation, this deliberate act of bridging realms. Similarly, the layout of a classic Hindu temple, the Vastu Purusha Mandala, is a square grid that represents the cosmos, with the central shrine symbolizing the world axis, Mount Meru. Worshippers move from the outer, profane square walls inward toward the sacred, central circle of the inner sanctum, retracing in miniature the geometric journey from earth to heaven. This philosophical foundation finds one of its clearest voices in the ancient Greek world, with the thinker Pythagoras and his followers. They did not see numbers as dry abstractions for accounting, but as the very fabric of reality. His famous declaration, "All is number," meant that harmony, proportion, and numerical relationships were the underlying principles of everything from musical scales to planetary motions to the human soul. A building constructed using these harmonious ratios, like the golden ratio, was not just beautiful, it was true. It resonated with the same mathematical order that governed the universe. To step into such a space was to step into alignment with cosmic law, to experience a physical echo of divine harmony. This idea flowed through history, influencing Plato, who in his dialogue Timaeus described the Creator using geometric forms to fashion the chaotic primal matter into the ordered cosmos. For these philosophers, geometry was literally the thought process of the divine. We see this metaphysical geometry reach a breathtaking crescendo centuries later in the Gothic cathedrals of medieval Europe. Here, stone seems to defy its own weight, soaring upward in ribbed vaults and pointed arches. This was not just a technical innovation allowing for larger windows and taller naves. The entire architecture was a theological text written in light and line. The floor plan, often in the shape of a cross, grounded the building in the earthly story of sacrifice. But the vertical lift, achieved through precise geometric ratios in the arches and pillars, was designed to pull the gaze and the spirit upward. The light streaming through vast stained glass windows, themselves intricate puzzles of geometric leading, was seen as divine illumination, literally filling the space with sacred presence. The cathedral was a machine for transcendence, using sacred geometry as its operating system to engineer an experience of the heavenly within the earthly confines. This leads us to a fascinating and subtle concept, the idea that these precisely shaped spaces could function as resonant chambers for spiritual energy. Just as a perfectly proportioned musical instrument vibrates at pure, clear frequencies, a room built with sacred proportions was believed to vibrate in harmony with the universe. Certain chambers in Egyptian temples or in underground structures like the Hypogeum of Malta may have been designed not just for visual ritual, but for sonic and vibrational effect. The geometry shaped the acoustics, which in turn could alter consciousness, deepen meditation, or amplify chant. The structure itself became an active participant in the ritual, a kind of architectural catalyst that transformed the space from an empty room into a charged vessel. This moves us fully from the realm of external measurement into the realm of internal experience, from what the building is to what it does to those within it. Ultimately, this symbolic dimension reveals the central impulse behind all this hidden geometry. It was an act of profound meaning-making. In a vast, often unpredictable universe, these cultures used the certainty of mathematics and the permanence of stone to create pockets of perfect order. They were mapping not just the earth or the stars, but the territory of the human spirit, seeking to locate their place within a grand, intelligible cosmos. The precise angle of a wall, the specific ratio of a chamber, the alignment of a doorway with a solstice sunrise, these were not random choices. They were deliberate inscriptions, a way of saying, we understand the rules, we see the pattern, and we are placing ourselves, our communities, and our devotion squarely within its harmonious framework. The monument was a prayer built in stone, a permanent statement of belief that the universe is not chaos but geometry, and that humanity, through intellect and reverence, could build a bridge to meet it. For centuries, the quest to understand these ancient wonders relied on the human eye, a tape measure, and a great deal of educated guesswork. We could admire the grand facades and theorize about alignments, but so much remained hidden, either buried by time, swallowed by jungle, or simply too vast and subtle to perceive from the ground. Today, however, we have been granted a kind of digital X-ray vision. We are no longer just observers, we are now forensic analysts equipped with tools that allow us to see through the earth and through the trees, to map with laser precision, and to test our wildest geometric hypotheses against cold, hard data. This technological leap is not just an upgrade, it is a revolution, transforming historical mystery into a quantifiable science and giving us our first true glimpse at the full scale of ancient design. The star of this revolution is a technology called LiDAR, which stands for light detection and ranging. Imagine flying over a dense, impenetrable rainforest in a small plane. Instead of a camera, the plane is equipped with a laser scanner that fires millions of invisible pulses of light toward the ground every second. Each pulse hits something, a leaf, a branch, the ground, and bounces back. By meticulously timing each return journey, a computer can build an astonishingly precise three-dimensional map of the terrain. digitally stripping away every single leaf and vine to reveal the bare earth below. The results have been nothing short of breathtaking. In recent years, LiDAR surveys over the jungles of Cambodia around Angkor Wat have revealed that the famous temple complex was not an isolated masterpiece, but the dazzling core of a vast, low-density urban sprawl covering hundreds of square miles, with intricate canal systems, roads, and smaller temples all arranged in a sophisticated geometric network. Similarly, in the Amazon, areas long thought to be pristine wilderness have been shown to contain the geometric footprints of enormous ancient settlements, with precise circular plazas and long, straight ceremonial roads, rewriting the history of human habitation in the Americas. LiDAR does not just find new sites, it reveals the true, intended canvas upon which the ancient architects worked, showing us their city-wide and even landscape-wide geometric visions for the first time. When we zoom in on individual structures, another tool takes over: three-dimensional laser scanning. Here, a scanner is placed on a tripod at a site like Petra in Jordan or the Roman Colosseum in Italy. It spins, firing a laser in every direction, capturing billions of data points to create a point cloud model of the structure that is accurate to within millimeters. This is how we discover the invisible. We can now detect tool marks left by specific ancient craftsmen, see the almost imperceptible wear patterns of millions of footsteps on stone floors, and identify subtle architectural features that have been eroded or obscured for millennia. Most importantly for our geometric search, this technology allows us to measure with God-like precision. We can determine if a wall that looks straight is actually straight, or if it curves by a fraction of a degree for a specific purpose. We can calculate the exact volume of a chamber or the perfect angles of a corner, moving our analysis from estimates to exactitudes. This data is the bedrock of modern understanding, replacing speculation with certainty and revealing engineering choices and symbolic intentions that were literally invisible to every generation before ours. All of this incredibly detailed, site-specific data then feeds into the final piece of the modern toolkit: digital cartography and geographic information systems, or GIS. This is where we move from the micro to the macro, from the single stone to the global pattern. Researchers can now take the precise coordinates of thousands of ancient sites from every continent and plot them on a digital globe. With powerful software, they can run complex analyses, testing long-held theories about ley lines or astronomical alignments on a scale that was previously impossible. For instance, they can digitally rewind the night sky over a site to the exact year of its construction and see which stars truly rose over which corner. They can calculate sightlines across hundreds of miles of terrain to see if one monument was intentionally placed to be visible from another. This global, data-driven approach is our filter for coincidence. It allows us to ask the big questions. When dozens of sacred sites across Europe seem to align along a straight path, is it statistically significant, or is it simply the result of having so many points on a map that some are bound to line up by chance? Digital cartography provides the mathematical framework to find an answer. Together, this suite of technologies, LiDAR, 3D scanning, and digital mapping, acts as a modern Rosetta Stone. It is our translation device for the ancient geometric code. Where previous researchers had fragments of text and weathered stones, we now have entire digital landscapes and millimeter-perfect models. This toolkit does more than confirm old theories. It constantly generates new, unexpected questions. It reveals that the ancient world was far more interconnected, planned, and mathematically sophisticated than we ever dared to assume from surface observation alone. Each new scan, each new map, is like turning on a light in a room we've been describing in the dark for centuries. We are no longer just telling stories about the past, we are auditing its blueprints, and what we are finding is compelling us to redraw the map of human history itself, one laser pulse at a time. Now let us shift our gaze from the vast digital maps in our computers to the intimate patterns found in a garden. Before we had lasers to scan the heavens, our ancestors were studying the spirals in pine cones and the arrangement of leaves on a stem. They observed a peculiar numerical harmony in the living world, a pattern so fundamental it seems woven into the fabric of life itself. This is the Fibonacci sequence. It begins simply enough, 1, 1. Then, each new number is the sum of the two before it, giving us 2, 3, 5, 8, 13, 21, and so on, expanding toward infinity. But the magic is not in the numbers alone, it is in the relationship between them. As the sequence grows, the ratio between a number and its immediate predecessor gets closer and closer to an irrational number roughly equal to 1.618, a value we know as the golden ratio, or phi. This is the proportion that the human eye finds instinctively pleasing, the same ratio that defines the graceful spiral of a nautilus shell, where each chamber grows precisely by this factor, and the mesmerizing swirl of seeds in a sunflower head, packed with maximum efficiency according to this ancient mathematical rule. When we step back and look at the greatest structures of antiquity with this knowledge, a fascinating possibility emerges. Were these builders not just engineers and astronomers, but also keen biologists, intentionally weaving this code of life into their stonework? Consider the Parthenon in Athens, the iconic temple atop the Acropolis. While its original wooden roof is long gone, the footprint of its marble platform and the proportions of its famous facade have been analyzed for centuries. Many architectural historians point out that the rectangular footprint of the temple, the spacing of its columns, and the relationship between its width and height all create rectangles that approximate the golden ratio. The design seems to breathe with an organic harmony, as if the building itself were a living entity growing from the rock, its proportions mirroring the same natural order found in a branching tree or an unfurling fern. It is a conscious application of a universal aesthetic principle, one believed to resonate with a deep, almost primal sense of beauty and balance. This concept travels across the world and back in time. In the dense jungles of Central America, the architects of the ancient Maya appear to have employed similar principles. The layout of ceremonial centers like those at Tikal or Palenque often reveals a sophisticated use of proportional planning. The stepped pyramids, the plazas, and the positioning of important stelae or altars frequently relate to one another through dimensions that reflect Fibonacci numbers or the golden ratio. For instance, the height of a temple platform in relation to the width of its stairway, or the distance between two major structures, might be designed as a 3:5 or 5:8 ratio. This was not random. In a world view where the cosmos, the natural world, and the realm of the gods were intimately connected, using the mathematics of life to shape a sacred space was a way to align human creation with cosmic creation. The temple became more than a building, it became an echo of the generative force of the universe. Perhaps the most debated and intriguing application of this idea brings us back to the Great Pyramid of Giza. Some researchers and mathematicians have proposed that the pyramid's very form encodes the golden ratio. One theory suggests that if you take half the length of its base and compare it to its slant height, the apothem, the ratio you get is remarkably close to phi. Another, more speculative idea looks at the internal passageways. If you imagine a grand spiral moving up through the pyramid's interior, passing through the endpoints of the descending corridor, the ascending corridor, and the grand gallery, the proportions of this theoretical spiral's growth are said to follow the Fibonacci sequence. While mainstream Egyptology often attributes the pyramid's proportions to simpler, well-documented architectural choices like the Sikht, the persistent presence of these harmonious numbers invites a deeper question. Could it be that the builders, in their quest to create a perfect, eternal form, intuitively or intentionally arrived at the same proportions that nature uses to build a perfect shell or flower. The convergence is too poetic to ignore. This was far more than simple imitation. Our ancestors were not just copying a pretty spiral from a seashell onto a temple wall. What we are seeing is the incorporation of a fundamental operating principle into static stone. They were embedding the very logic of growth, efficiency, and natural harmony into their architecture. A sunflower uses the Fibonacci spiral to pack the maximum number of seeds into the smallest space, a design of breathtaking efficiency honed by millions of years of evolution. When an ancient architect used the same ratio to determine the width and height of a doorway, they were, in a profound sense, infusing that doorway with the intelligence of nature. They were creating structures that felt inherently right, inherently stable, and inherently connected to the living world. This represents a staggering depth of understanding. It reveals a mindset that did not separate mathematics from biology or art from engineering. They saw a unified pattern language governing everything from the microscopic to the monumental, and they sought to speak that language in their most enduring works. In doing so, they built a bridge between the organic and the constructed, reminding us that the highest human artistry strives to reflect the deepest truths of the natural world. But geometry is not a silent art. The stones we have been examining, these massive monuments of precise angles and celestial alignments, hold another secret, one that is not seen but heard. Across the world, in dark chambers and atop towering pyramids, there exists a hidden layer of design that speaks directly to our sense of hearing. This is the world of acoustic geometry, where the very shape of a space was engineered to transform sound into an experience of awe and power. Imagine standing deep underground on the Mediterranean island of Malta, within the Hal Saflieni hypogeum, a labyrinthine burial complex carved from solid limestone over 5,000 years ago. You enter a small, oval chamber known as the Oracle Room. If a person with a deep voice chants a specific tone into a small niche in the wall, something extraordinary happens. The sound does not just echo, it amplifies and modulates, vibrating through the stone with an intensity that can be felt in the bones. This resonant frequency, researchers have found, fills the entire three-level structure, a phenomenon that would have been utterly mystical to those experiencing it in flickering torchlight. The geometry of this chamber, its curved walls and specific dimensions, acts as a perfect natural resonator, turning a human voice into something superhuman, something oracular. Travel across the Atlantic to the jungles of the Yucatan Peninsula, to the grand Mayan city of Chichén Itzá. Here, before the magnificent stepped pyramid of El Castillo, dedicated to the feathered serpent god Kukulkan, visitors discover a different auditory marvel. If you stand at the base of the grand staircase and clap your hands, the sound that returns is not a simple echo. It is a sharp, chirping tone that uncannily resembles the call of the Quetzal bird, a sacred creature deeply associated with divine authority and the Maya elite. This is not an accident of the environment. The step design of the pyramid, with its alternating vertical and horizontal surfaces, acts like a giant sound diffraction grating. The sound waves from the clap scatter off the steps, returning to the listener in a series of rapid, descending pulses that our ears interpret as that distinctive bird chirp. The builders, through an intuitive or calculated understanding of how sound interacts with their architecture, embedded the voice of the sacred into the very facade of their temple. Every clap became a ritual invocation, a symbolic conversation with the divine made audible through stone. Even the silent, imposing mass of the Great Pyramid of Giza is not immune to these acoustic speculations. The long, narrow, and corbelled Grand Gallery, with its soaring ceiling, presents a unique acoustic environment. Some acousticians and researchers have proposed that this sloped corridor was not just a passageway, but a giant sound amplifier. Specific frequencies of chanting or instrument playing, perhaps from a chamber below, could have been focused and directed up the gallery, emerging into the king's chamber with amplified power. The chamber itself, built entirely of hard granite, with its unique dimensions and empty sarcophagus, might have functioned as a resonant cavity. Experiments have shown that certain low frequencies cause the granite walls to vibrate in a way that creates standing waves, patterns of resonance that can produce unusual auditory effects, making sounds seem to come from everywhere and nowhere at once. While we lack definitive proof that this was intentional, the possibility invites us to consider a more multisensory ritual experience, where geometry shaped not only space and light, but also the very air and sound within it. This growing body of inquiry has given rise to a formal field of study known as Archaeoacoustics. Scientists and archaeologists are now using sophisticated audio equipment to map the resonant frequencies of ancient sites, from the stone circles of Britain to the underground temples of Peru. They are asking a fundamental question: were these astounding acoustic effects a happy coincidence of construction, or were they a deliberate design feature? The evidence increasingly points toward intention. At sites like Newgrange in Ireland or the underground temples of Hal Saflieni, the acoustic properties are too pronounced and too consistent to be easily dismissed. It suggests that ancient priests or architects possessed a practical, if not formally scientific, understanding of sound waves. They learned through experimentation that a chamber of a certain shape and size, built with specific materials, could dramatically alter the human voice, could make it ring with authority, or mimic the calls of sacred animals. This acoustic design would have been a potent tool in ritual. Imagine the psychological impact of a chant that seemed to emanate from the stones themselves, or a priest's voice that filled a cavernous space with unnatural clarity and volume. It was a technology of awe, using geometry to manipulate perception and create an undeniable sense of the numinous. This revelation adds a profound new dimension to our map of hidden geometry. It tells us that the ancient master builders were not just visual artists or celestial mathematicians, they were also composers of space. They designed for the ear as meticulously as for the eye. The harmony they sought was not only in the proportions of a rectangle or the alignment with a star, but also in the resonance of a chamber. It was a holistic approach to sacred architecture, where every aspect of human sensation was considered a pathway to the divine. The stones, it seems, were not meant to be silent monuments to the past. They were designed to sing, to chant, to whisper secrets in frequencies that still, to this day, vibrate with the echo of ancient intention. This layer of sensory geometry reminds us that to truly understand these places, we must sometimes close our eyes and simply listen. While the ancients looked upward to chart the heavens, they also cast their gaze across the earth, drawing lines of power and meaning directly upon the landscape itself. This practice moves us from the celestial to the terrestrial, from archaeoastronomy to what we might call sacred geography. Here, geometry was not just about abstract ratios or star positions, but about anchoring a monument, a city, or an entire ceremonial complex into the very bones of the living world. It was a way of saying, we belong here and this place belongs to us, through a language of sightlines, alignments, and deliberate placements that connected human ambition to sources of water, mountain guardians, and the life-giving path of the sun. Consider the Great Pyramid of Giza once more, not in isolation but as part of a vast geographical canvas. Some researchers have noted a fascinating terrestrial relationship, that the pyramid's southeastern corner aligns almost perfectly with the apex of the Nile Delta, the fertile, fan-shaped region that was the absolute lifeblood of ancient Egypt. This was no accident of desert real estate. By orienting their most eternal monument toward the source of their civilization's agricultural and economic power, the pharaohs were making a profound statement. The pyramid became a permanent stone anchor point in a geodetic network, symbolically tethering the king's eternal authority to the land's fertility. It was a declaration that the pharaoh's power was as fundamental and nourishing as the Nile's annual flood. This conversation between monument and landscape finds its most iconic expression just a short distance away in the enigmatic gaze of the Great Sphinx. Carved from the living bedrock of the Giza Plateau, this colossal guardian is not staring blankly into the eastern horizon. On the morning of the spring equinox, an observer standing before the Sphinx would witness a breathtaking alignment as the sun rises directly along its line of sight. The spring equinox, a day of perfect balance between light and dark, marked a time of renewal and rebirth in the ancient Egyptian calendar. By aligning the Sphinx's gaze with this specific solar event, the builders fused astronomy, topography, and symbolism into a single, powerful image. The Sphinx, often associated with the sun god and royal power, was forever linked to the cyclical rebirth of the sun, and by extension, the land of Egypt itself. It was not merely a statue, but a permanent participant in an annual cosmic drama, its stone eyes witnessing the promise of renewed life with every passing year. To see this principle of topographical alignment on a truly monumental scale, we must journey to the arid plains of southern Peru, home to the world-famous Nazca lines. These vast geoglyphs, etched into the desert pavement over 2,000 years ago, present a puzzle that is only fully comprehensible from the air. While many are familiar with the intricate animal figures, the spider, the hummingbird, the monkey, the majority of the Nazca markings are in fact geometric, miles-long straight lines, trapezoids, and spirals that stretch across the landscape like a giant sketchbook. For decades, the purpose of these lines fueled wild speculation. However, modern research, combining satellite imagery with on-the-ground archaeology, has revealed a compellingly practical and spiritual logic. Many of the longest, straightest Nazca lines point unerringly toward distant sources of water, such as mountain springs or sections of underground aquifers, visible as greener patches in the foothills of the Andes. In a desert environment where water was synonymous with survival, these lines likely served as ceremonial pathways, guiding processions to vital locations during rituals pleading for or giving thanks for water. Other lines and figures align with specific peaks in the Andes that were considered sacred, or apus, mountain deities believed to control weather and water. The geometry here functioned as a gigantic, walkable map and a prayer simultaneously, directly linking the people on the plain to the distant, life-sustaining forces of their world. It was a way of inscribing their dependency and reverence onto the land itself, turning the entire region into a ritual landscape where every line told a story of need, gratitude, and connection. This practice of weaving architecture into the terrain is a global phenomenon. In ancient Greece, temples were often placed to emphasize a relationship with a striking natural feature. The Temple of Apollo at Delphi, for instance, seems to erupt from the slopes of Mount Parnassus, its placement amplifying the site's reputation as the mystical navel of the world. In Cambodia, the main entrance causeway to Angkor Wat aligns not only with the western sunrise on the equinox, but also directs the viewer's eye toward the distant, sacred mountain of Phnom Kulen. Across Mesoamerica, Maya pyramids were frequently built atop natural hills or were oriented to frame views of specific peaks considered the homes of ancestors or gods. This was more than just finding a nice view. It was a conscious act of geomancy, the art of arranging structures in harmony with the spiritual and energetic currents of the land. By aligning a temple with a mountain or a spring, the builders were tapping into that place's perceived power, borrowing its permanence and sanctity for their own construction. The geometry became the connective tissue, the visible line of relationship that showed everyone, from the highest priest to the lowest laborer, how their world was ordered, where the sources of life and danger lay, and how their human-made wonders fit into that greater natural scheme. Ultimately, this geometry of power reveals a dual purpose, both pragmatic and profound. On one hand, these alignments served immensely practical needs. Orienting a city toward a river delta ensured economic and logistical connection. Pointing lines toward water sources in a desert was a matter of communal survival. Siting a monument to the equinox sun created a reliable annual calendar for planting and harvest. On the other hand, these actions carried deep spiritual and political weight. They expressed a culture's understanding of its place in the cosmos, claiming the landscape by integrating with it. A pharaoh aligning his tomb with the Nile was asserting that his rule was as essential as the river. A Nazca priest walking a line toward a mountain spring was performing a ritual that reinforced the social order and their relationship with the divine. This terrestrial geometry transformed the land from a mere setting into an active character in the human story, a silent partner in ceremony and a canvas upon which power, both earthly and celestial, was permanently inscribed. It reminds us that for our ancestors, the sacred was not somewhere else. It was right here in the river that fed them, the mountain that watched over them, and the horizon where the sun was reborn. And they used every tool at their disposal, including the silent, sure language of lines and angles, to chart that sacredness onto the world they called home. The thread of sacred geometry, though stretched thin through centuries often called dark, was never truly broken. It was merely waiting for a moment of reawakening, a cultural rebirth that would once again seek to measure the world, the heavens, and humanity itself with a compass and a straight edge. That moment arrived with the Renaissance, a period whose very name means rebirth, and it was fueled not by discovering something new, but by consciously recovering something profoundly old. After the long medieval era, European thinkers turned with fresh eyes to the surviving texts and ruins of classical antiquity, seeing in them not pagan relics but a lost language of perfection. This was not a passive rediscovery, it was an active quest, and it transformed artists into scientists and architects into philosophers. The hidden codes of the pyramids and the Parthenon were about to find new expression in the cathedrals, canvases, and treatises of a world stepping into the light. No single figure embodies this fusion of ancient wisdom and restless inquiry more completely than Leonardo da Vinci. A painter, inventor, anatomist, and engineer, Leonardo was obsessed with understanding the underlying principles of nature, and he believed those principles were mathematical and geometric. His iconic drawing, The Vitruvian Man, is far more than a beautiful sketch of a man in two poses. It is a direct homage to the Roman architect Vitruvius, who, centuries before, had written that the ideal human form could be perfectly inscribed within both a circle and a square. Leonardo was not just illustrating an old idea, he was verifying it through his own meticulous study of human anatomy. In that single image, the microcosm of man is shown to contain the fundamental shapes of the cosmos, the square representing the material world and the circle symbolizing the spiritual and eternal. The navel Leonardo showed is the geometric center of the circle, while the groin forms the center of the square. The outstretched limbs touch the circumference, and the proportions between facial features, the length of arms to torso, all adhere to harmonious ratios like the golden mean. For Leonardo, this was proof that the same divine geometry that ordered the heavens was also the blueprint for humanity. He was literally mapping the hidden architecture of the human body, declaring that we ourselves are the ultimate masterpiece of sacred geometry. While Leonardo explored the geometry within, architects of the Renaissance were rediscovering how to project it outward onto the world, and they did so by becoming archaeologists. Filippo Brunelleschi, the genius behind the immense dome of the Florence Cathedral, famously traveled to Rome with his friend, the sculptor Donatello. There, they did not just admire the crumbling ruins, they became forensic investigators of form. Brunelleschi meticulously measured the proportions of ancient structures like the Pantheon, sketching, calculating, and reverse engineering the classical orders. He was deciphering the lost construction manuals of the Romans, understanding how they used geometry to create both staggering beauty and impossible stability. His breakthrough for the Florence dome was a geometric marvel, a self-supporting double shell built without the need for massive wooden centering, using a herringbone brick pattern that followed precise mathematical curves. He did not copy the Pantheon, he understood its principles and then surpassed them, using recovered ancient geometry to solve a modern architectural crisis and crown his city with a symbol of its new intellectual dawn. This geometric revival quickly became the formal language of the age, woven into the very fabric of Renaissance art and architecture. Painters like Piero della Francesca wrote treatises on perspective, using geometric grids to create the illusion of three-dimensional depth on a flat surface, literally constructing reality through mathematical law. In architecture, the designs of Leon Battista Alberti, Andrea Palladio, and others are textbooks of applied sacred geometry. Churches like Santa Maria Novella in Florence have facades whose dimensions are pure expressions of simple ratios and Pythagorean harmonies. Palladio's villas in the Venetian countryside are exercises in symmetrical perfection, their floor plans and elevations governed by interlocking squares, circles, and the golden rectangle. Even the placement of windows, the height of columns, and the span of arches were determined not by whim, but by a conscious return to the ancient belief that beauty is not subjective, it is a demonstrable mathematical fact. This was a conscious revival, a deliberate choice to build a new world using the recovered operating system of the old one. The Renaissance thus serves as the essential historical bridge, the missing link in our map of hidden geometry. It proves that the knowledge was not extraterrestrial or the sole property of one lost super-civilization, but a human intellectual heritage that could be lost, found, and brilliantly reapplied. The thinkers of this period became the translators, taking the symbolic, often ritualistic geometry of the ancient world and formalizing it into a coherent design philosophy that would shape Western art for centuries. They showed that the impulse to find cosmic order in form is a continuous thread in human culture, capable of lying dormant only to re-emerge with even greater force. From the pyramids to the Parthenon, and from the ruins of Rome to the soaring domes of Florence, the language of shape, ratio, and alignment speaks of a perennial human quest, not for mere decoration, but for a fundamental understanding of harmony, a quest that would soon take this recovered geometry in startling new directions as the world of science began to dawn. Now, as we marvel at these intricate patterns spanning continents and millennia, a crucial and sobering question must be asked. Are we, in our enthusiasm to connect the dots, actually seeing a picture that was never drawn? This is the essential counterpoint from a significant school of academic thought, a necessary dose of skepticism that ensures our map is charted on bedrock, not shifting sands. Critics, often working within the framework of procedural archaeology, which emphasizes practical, environmental explanations, raise a powerful objection. They suggest that what we celebrate as intentional hidden geometry might simply be the product of three things: the limitations of ancient tools, the boundless capacity of the human mind to find patterns, and the relentless laws of statistics. First, consider the margin of error. When we measure the alignment of a 4,000-year-old pyramid to true north and find it off by a fraction of a degree, we are using laser theodolites and satellite GPS. The builders had wooden rods, stone benchmarks, and perhaps a simple sighting instrument called a Merck hit using a plumb line. Achieving what they did with such tools is already staggering, but to insist that every minute deviation was a deliberate encoding of pi or the speed of light may be to impose a modern standard of precision on a pre-industrial process. The functionalist argument is that these structures were built to be astronomically functional and symbolically powerful, not to serve as cryptographic textbooks. A doorway aligned to the solstice sunrise needed to be functionally accurate enough for the light to hit the altar, not mathematically perfect to the thousandth of a degree. The awe, they argue, should lie in the brilliant practicality of their methods, not in attributing to them a flawless, almost supernatural exactness they may not have possessed or even sought. This leads to the second, and perhaps most important, psychological critique, apophenia. This is the human tendency to perceive meaningful connections between unrelated things. We are pattern-seeking creatures. It's how we navigate the world. We see faces in clouds and constellations in random stars. When presented with a complex ancient structure with dozens of angles and measurements, if we search long enough with a calculator, we will inevitably find numbers that resemble pi, phi, or the gravitational constant. The question is, did the builders put them there, or did we, like a cosmic Rorschach test, project them onto the stones? Critics point to numerous cases where elaborate geometric and astronomical theories have been debunked upon closer, more rigorous examination. The so-called battery chamber in the Great Pyramid, once theorized to be an ancient power plant component, is understood by most Egyptologists as a simple construction gap. Some claimed alignments at Stonehenge, when tested against the actual horizon as it existed 4,000 years ago, failed to match up. This pattern finding is not dishonest. It's a natural byproduct of our fascination, but it requires the discipline to separate compelling, reproducible alignments from cherry-picked numerical coincidences. Finally, there is the sheer weight of numbers. Statisticians often remind us of the law of truly large numbers. With tens of thousands of ancient monuments spread across the globe, built over a span of 10,000 years, some are bound by pure chance to align with specific stars, form geometric shapes with distant mountains, or have dimensions that ratio to modern mathematical constants. If you measure enough things, you will find surprising matches. The critic's challenge is this: for every site like Newgrange, where the winter solstice alignment is undeniable and dramatic, how many other proposed alignments fall within a broad, ambiguous window that could fit several different stars or sun positions? Without a clear, repeated cultural pattern or corroborating textual evidence, an alignment might be accidental, a fortunate byproduct of a building's orientation toward a river or a sacred mountain, rather than a deliberate star map. This skeptical perspective is not meant to dismantle the mystery but to refine it. It forces us to raise our standards of evidence. It asks us to look for clusters of clues where geometry, astronomy, mythology, and repeated construction practice all point in the same direction. The alignment at Choco Canyon is compelling not just because a dagger of light appears, but because it appears on the wall of a carefully engineered spiral petroglyph that also marks the lunar standstill cycle. The geometry of the Parthenon is persuasive because we have historical records from the Greeks themselves discussing their pursuit of optical refinement and harmonic proportion. By engaging fairly with these criticisms, we move from a realm of speculative fantasy into a more robust field of inquiry. We learn to ask not just what patterns we can find, but why the builders might have intentionally created them, what tools they realistically had, and what the preponderance of evidence across a culture truly suggests. This disciplined scrutiny doesn't diminish the wonder. It grounds it, making the genuine mysteries that withstand such examination all the more profound and real. Amidst the grand alignments and cosmic ratios, a more humble but equally revolutionary idea emerges from the rolling landscapes of Neolithic Europe. It is the notion of a common ruler, a shared tape measure used by Stone Age architects from the Scottish Isles to the plains of France. This is the controversial hypothesis of the megalithic yard, and its implications, if true, would fundamentally reshape our map of the ancient world's hidden connections. The story begins not with an archaeologist, but with an Oxford professor of engineering named Alexander Thom. In the mid-20th century, Thom embarked on a monumental personal survey, meticulously measuring hundreds of stone circles, alignments, and burial mounds across Britain and Brittany. He wasn't just looking at their orientations, he was obsessively recording their dimensions, their diameters, the spacing between stones, and from this avalanche of data, a pattern seemed to crystallize. Thom proposed that these diverse monuments were not laid out with random paces or local whims, but with a standardized unit of length. He called it the megalithic yard, equivalent to about 2.72 feet, or roughly 83 centimeters. More astonishingly, he argued that this yard was subdivided into a precise 40 megalithic inches, and that builders even used a standardized megalithic rod of 2.5 of these yards. According to his analysis, this exact unit could be found as the fundamental building block in the geometry of sites as famous as Stonehenge and as remote as Callanish in Scotland's Outer Hebrides. The immediate implication is staggering. It suggests that 5,000 years ago, across a vast and topographically challenging region, disparate communities of builders were working from the same blueprint, or at the very least using the same set of tools. This points not to isolated tribes occasionally raising stones, but to a coordinated, knowledgeable, and perhaps even professional class of surveyor engineers who traveled or whose techniques were disseminated across the continent. It implies a shared intellectual foundation, a Neolithic scientific tradition that had standardized its most basic element, the unit of measure. This is where the controversy ignites. For many mainstream archaeologists, Thom's megalithic yard is a classic case of seeing a pattern in the noise. They raise a formidable critique. First, they question the data itself. Thom measured the centers of stones that are often irregular, partially buried, or may have shifted over millennia. Establishing the exact intended center point of a crude megalith is an interpretative act, not an exact science. Slight variations in choosing where to place your measuring tape could nudge a diameter measurement into or out of alignment with a theoretical unit. Second, and more statistically damning, is the argument of flexibility. Critics point out that Thom's megalithic yard is not a single, rigid number, but a range centered on that 2.72-foot mark. With a little mathematical leeway, they argue, you can fit a hypothetical unit to a wide array of measurements, especially when you have the freedom to also use multiples and fractions of that unit. It's a bit like saying that because you can divide the height of many adults by a number close to 6, humans must have been designed using the foot as a unit. The coincidence may be persuasive, but it isn't conclusive proof of intent. To better understand this tension, it helps to compare the megalithic yard to an ancient unit that we know with absolute certainty did exist, the Egyptian royal cubit. Unlike the hypothetical yard, the royal cubit is not an abstraction derived from measuring ruins. We have physical artifacts, beautifully crafted cubit rods made of stone and wood, found in tombs and temples. These rulers, typically about 20.6 inches long, were divided into 7 palms and 28 digits. We have builders' notes and diagrams that explicitly use this unit. The cubit was the backbone of Egyptian architecture, and its standardization was an act of state power and administrative control, managed by the priesthood and the pharaoh's overseers. The evidence for it is tangible and direct. The quest for the megalithic yard lacks such a smoking gun. No one has found a Neolithic ruler etched with megalithic inches. The evidence is entirely circumstantial, residing in the mathematics of the monuments themselves. Proponents, however, counter that the consistency Thom found is too widespread to be ignored. They argue that the repeated appearance of simple Pythagorean triangles in the layouts of these sites, triangles which only work if the sides are in whole numbers of megalithic yards, is a powerful indicator of intentional design. The debate ultimately hinges on a deeper question about Neolithic society. Was it capable of such widespread standardization? The diffusionist view, which the megalithic yard supports, imagines seafaring experts, a kind of Stone Age guild, spreading a unified tradition of sacred geometry. The opposing, isolationist view sees communities developing their own local approaches, with similarities arising from common human cognitive patterns and shared practical challenges, like using the human stride or the pendulum swing of a rope to derive approximate measures. Perhaps the most compelling middle ground is that the megalithic yard represents not a rigid, bureaucratically enforced standard, but a natural, organic unit that emerged from a ubiquitous Neolithic practice. Some researchers have proposed it could be derived from a pendulum that beats a certain number of times per day, or from an average of human pace lengths during ritual procession. In this light, it wouldn't be an imposed rule, but a discovered rhythm, a unit that felt naturally right across different cultures because it was rooted in a common human experience of the body and the cosmos. Whether a precise standard or a recurring natural rhythm, the persistent ghost of this measurement in the data invites us to reconsider the connections between our ancient ancestors. It suggests that the geometry we map was not just a silent, abstract code, but a living, practical language spoken with a shared vocabulary of length and angle, a language whose first word may have been a unit of measure about the length of a long stride, echoing across the plains and through the ages. While the debate over a shared megalithic yard unfolds in the green hills of Europe, an entirely different expression of ancient geometry reveals itself in the stark, arid plains of Peru. Here, the scale of ambition shifts dramatically, from the intimate spacing between standing stones to designs so vast they can only be comprehended from the heavens. This is the realm of geoglyphs, where geometry is not built upward with stone upon stone, but etched directly into the skin of the earth itself, a form of mapping that uses the entire landscape as its parchment. The Nazca lines are the most famous example, a series of immense drawings spread across nearly 200 square miles of desert plateau, but to call them mere drawings is a profound understatement. They are exercises in precision executed on an almost unimaginable scale. We find perfectly straight lines that run arrow straight for over 30 miles, cutting across valleys and hills without deviation. There are colossal trapezoids that fan out like giant runways, immense triangles, and spirals that lock into perfect geometric sequences. Then there are the biomorphs, the stylized figures of a hummingbird, a spider, a monkey, each composed of a single, unbroken line that curves and loops with a draftsman's confidence. The technical achievement is baffling. The Nazca people, between 2,000 and 1,500 years ago, created these forms by simply removing the top layer of dark, sun-baked pebbles to expose the lighter clay beneath. The desert's hyper-arid climate preserved them, but the process of design and execution is the real mystery. How do you map a 300-foot-long hummingbird with a perfectly curved beak onto uneven terrain when you cannot see the whole picture? The builders likely used a system of scaling up from small models. They could have laid out a master design on a smaller grid and then transferred that grid, stake by stake and rope by rope, onto the gigantic grid of the desert floor. This required an advanced understanding of surveying to maintain proportions and angles over vast distances, likely using simple sighting poles to keep those 30-mile lines perfectly straight. It was geometry made physical through patience and collective effort. The purpose of these sprawling designs plunges us into the heart of the mystery. One prominent theory, championed by researcher Maria Reich, is that they served as an astronomical calendar. Certain lines do align with the solstice sun, and some shapes may correlate with star clusters important to Nazca cosmology. They could have been giant observatories where walking the lines or gathering at specific intersections marked sacred times in the agricultural and ceremonial cycle. Another compelling idea is that they were ceremonial pathways. In Andean tradition, the landscape itself is alive, infused with spiritual force known as huaca. These lines or sects are believed to have been processional routes connecting sacred points like mountains and springs, creating a ritual map of the territory. By walking these lines, people were not just moving across the land, they were tracing a sacred geometry that connected them to the powers of the earth and sky. A more speculative theory suggests the lines were meant for the gods themselves to see from above, perhaps as messages or offerings to deities believed to dwell in the sky or the mountains. This idea captures the sheer scale of the endeavor, a geometry not for human eyes at ground level but for a celestial viewer, yet this perspective also challenges our assumptions. It forces us to consider that ancient cultures might have conceived of a viewpoint beyond their own physical limitations, designing for an idealized panoramic vision that they could hold in their mind's eye even if they could never physically witness it. The Nazca lines are not alone. On the other side of the world, the chalk hills of England bear similar colossal figures like the Uffington White Horse. This abstract, stylized horse, formed from trenches filled with white chalk, is nearly 400 feet long and dates back possibly 3,000 years. It is a figure of sweeping, elegant curves that can only be fully appreciated from the air or the distant valley below. Its purpose is similarly enigmatic, likely tied to tribal identity, worship of a horse goddess, or celestial symbolism. And then there are the geometric earthworks of North America, like the Great Serpent Mound in Ohio, a winding, quarter-mile-long effigy mound shaped like a coiling snake, built by ancient indigenous cultures. Its curves align with astronomical events, such as the summer solstice sunset, blending zoomorphic form with precise celestial observation. What unites these disparate geoglyphs across continents is a shared impulse to impose meaningful, geometric order onto the natural landscape at the maximum possible scale. This is geometry as an act of claiming, of inscribing human belief and identity onto the very face of the earth. It represents the ultimate fusion of the symbolic and the practical. The straight lines demonstrate a mastery of surveying that could be used for irrigation, territorial division, or constructing other monuments. The precise curves and shapes demonstrate a sophisticated artistic and mathematical sensibility. But together they create something more than a tool or a decoration. They create a permanent, interactive map. This map isn't drawn on papyrus or stone, it is the territory. To walk the Nazca lines was to navigate a ritual diagram. To view the white horse from the valley was to witness a tribal emblem woven into the land itself. This practice of large-scale earth art reveals a final, breathtaking dimension of our hidden geometry map. It shows that ancient cultures didn't just build structures on the landscape, they conceived of the landscape as a structure. They saw the hills, plains, and deserts as a living canvas, and with simple tools and profound collective will, they drew upon it the same sacred language of lines, angles, and shapes we find in their temples and tombs, proving that their geometric vision was as boundless as the earth they called home. Stepping back from the colossal earth art of the Nazca Plains, we must now sharpen our focus to the precise, elegant language that underpins all these grand designs, the raw numbers themselves. Beyond the sweeping shapes and celestial alignments lies a layer of pure mathematics, a set of constants and relationships that appear with such frequency in ancient structures that they cannot be easily dismissed as artistic whim. This is where our investigation moves from observation to calculation, to the specific roles of pi, phi, and the deceptively simple power of the Pythagorean triple. Let's start with perhaps the most famous and contentious example, the Great Pyramid and pi. The relationship is striking. If you take the pyramid's perimeter at its base and divide it by twice its original height, the result is a number extraordinarily close to pi, approximately 3.1416. This has led many to proclaim that the ancient Egyptians encoded this fundamental constant into their monument over 2,000 years before Archimedes is credited with its calculation. But is this intentional or a fascinating byproduct? Skeptical archaeologists offer a compelling alternative rooted in the builder's own methods. The Egyptians used a unit of measure called the royal cubit and a concept known as the seat, which defined the slope of a pyramid. It represented the horizontal run for every 1 cubit of vertical rise. For the Great Pyramid, the chosen seat was 5.5 palms. When you construct a pyramid with this specific seat, the geometry automatically produces that pi-like ratio between perimeter and height. In this view, the Egyptians were brilliant practical geometers, not theoretical mathematicians. They may not have been thinking of pi as an abstract constant, but their chosen slope, likely for structural and aesthetic reasons, inadvertently locked that mathematical relationship into stone. This doesn't diminish their genius, it reframes it. It suggests their mastery was so profound that they harmonized with universal mathematical truths through practical craft, achieving a result that later civilizations would need complex theory to articulate. Then we have phi, the golden ratio, approximately 1.618. This number, represented by the Greek letter phi, appears throughout nature in the spiral of shells and the arrangement of seeds in a sunflower. Its aesthetic appeal is powerful, creating a proportion that the human eye finds inherently pleasing. We see claims of phi in the Parthenon's facade, in the layout of the Giza complex, and in the proportions of countless temples and artworks. The challenge here is distinguishing between a deliberate application and a posteriori analysis. Because the golden ratio produces such a pleasing shape, it's tempting for modern researchers to find it everywhere, sometimes by selectively choosing which points to measure. However, there are compelling cases. The design of the Great Pyramid's King's Chamber, for instance, forms a double square rectangle, and the geometry of its walls and sarcophagus can be shown to generate golden ratios. More convincingly, the Fibonacci sequence, which approximates phi, seems embedded in the very growth patterns of nature that ancient cultures revered. Whether they understood the number itself or were intuitively replicating the harmonious proportions they observed in the living world, the effect is the same: architecture that resonates with a fundamental pattern of creation. This brings us to a more grounded yet equally brilliant mathematical tool, the Pythagorean triple. Centuries before Pythagoras formulated his famous theorem about right-angled triangles, ancient builders were using its principles with remarkable skill. A Pythagorean triple is simply a set of 3 whole numbers that perfectly satisfy the theorem, like 3, 4, and 5, or 5, 12, and 13. These triples provided a foolproof, hands-on method for creating perfect right angles, the absolute cornerstone of stable construction and precise alignment. Evidence suggests this technique was used globally. A Babylonian clay tablet known as Plimpton 3222, dating to around 1800 BC, contains a table of Pythagorean triples, indicating a formal understanding of these relationships. In practice, a builder could take a rope, knot it into 12 equal segments, and stretch it to form a triangle with sides of 3, 4, and 5 segments. The angle between the 3 and 4 segment sides would be a perfect 90 degrees. This simple but ingenious technique, sometimes called rope stretching or cord knotting, could have been used to lay out the square bases of pyramids in Egypt, the foundations of temples in Mesopotamia, and the orthogonal street grids of the Indus Valley. It represents a democratization of advanced geometry, a complex mathematical truth reduced to a practical, repeatable action accessible to master builders across the ancient world. When we pull back to view pi, phi, and Pythagorean triples together, a profound picture emerges. These are not separate curiosities but different expressions of a unified ancient intellect engaging with the fabric of reality. Pi connects to the circle and the cycle, to the heavens and perpetual motion. Phi connects to life, growth, and organic beauty. The Pythagorean triples connect to the earthly grid, to stability, order, and the very possibility of raising a structure that won't collapse. The builders may not have articulated them as we do in modern algebra, but they operationalized them. They turned cosmic constants and abstract relationships into tangible rules of thumb, into specific seats, into knotted ropes, into proportional canons passed down through guilds of craftsmen. This is the hidden geometry at its most potent. It is applied mathematics fused with cosmology. The numbers were not just for calculation. They were considered sacred because they were seen as the immutable laws according to which the universe was built. To build with these numbers was to participate in that cosmic order, to make a human-made object resonate with the same harmony that governs the stars and the seasons. So, were they brilliant mathematicians in our modern sense? Perhaps not. But they were consummate geometers who understood that the physical world could be mapped, measured, and mirrored through a language of shape and number, leaving behind a legacy in stone that continues to challenge and inspire our own understanding of their world and of the mathematical truths that bind us all. From the universal constants of pi and phi, we turn now to a blueprint that was not merely inspired by the cosmos, but was reportedly delivered from a divine source itself. The Temple of Solomon, as described in the Hebrew Bible, presents one of history's most influential examples of sacred geometry, where precise mathematical instructions become the very language of revelation. According to the biblical narrative, this was not a design born from human trial and error or even celestial observation alone. The first book of Kings details that King David received the plans for the temple directly from divine inspiration, which he then passed to his son Solomon to execute. The text goes into remarkable detail, providing specific measurements for the structure, its inner sanctuary, its furnishings, and its iconic features. We are told the temple was 60 cubits long, 20 cubits wide, and 30 cubits high. It featured a portico, a main hall, and an inner sanctum known as the Holy of Holies, which was a perfect cube, 20 cubits on each side. Flanking the entrance stood two enormous bronze pillars named Jachin and Bows, each with intricate capitals decorated with networks of chainwork and rows of pomegranates. This is not just an architectural description, it is a geometric prescription. The proportions here are deeply symbolic. The ratio of the main hall's length to its width is 3:1, a number of completion and divine perfection in the biblical tradition. The Holy of Holies as a perfect cube represents a microcosm of a perfected, sacred space, a concept echoed later in the cube-shaped Kaaba in Mecca and in descriptions of the heavenly Jerusalem. The pillars, Jachin meaning he will establish and Bows meaning in him is strength, framed the entrance not just physically but symbolically, representing the stable, enduring nature of the covenant between the divine and the people. What makes this so compelling for our exploration is that it positions geometry as the essential intermediary. The ineffable divine will is translated into buildable, measurable form through numbers and ratios. The perfect instructions from heaven required perfect execution on earth, implying that the craftsmen, led by the artisan Hiram of Tyre, possessed a masterful understanding of sacred geometry to translate this spiritual blueprint into physical reality. This idea that the divine realm operates on principles of perfect geometry that can and should be mirrored in earthly worship created a powerful template that would resonate for millennia. Its influence extends far beyond the historical, short-lived temple itself. Centuries later, this geometric and symbolic blueprint was profoundly adopted and elaborated upon by the traditions of Freemasonry. For Freemasons, the Temple of Solomon is the ultimate archetype of sacred architecture. The measurements, the pillars, the concept of the master builder all become layered with moral and philosophical meaning. The geometry is seen as a vehicle for spiritual instruction, where the use of the square, the compass, and the plumb bob are not just tools for constructing a building, but tools for constructing a virtuous life. The Masonic fascination with this temple underscores a central theme, that the act of building with intentional, sacred proportions is itself a spiritual discipline, a way of aligning human endeavor with a higher, eternal order. This tradition powerfully demonstrates how a specific set of geometric instructions, rooted in one ancient text, could fuel an entire symbolic and philosophical system dedicated to the pursuit of moral and intellectual enlightenment through architectural metaphor. When we place the Temple of Solomon alongside the pyramids of Giza or the mandalas of Angkor, we see a fascinating parallel, yet with a distinct origin story. In Egypt or Cambodia, the geometry often emerges from an observation of the natural and celestial worlds, a human effort to map the cosmos. In the biblical account, the geometry descends from the divine realm as a direct gift, a revealed truth to be materialized. This highlights a crucial duality in the ancient world's relationship with hidden geometry. For some, it was a discovered language decoded from the stars and the seasons. For others, it was a revealed language delivered through prophecy and vision. Yet both paths lead to the same profound conclusion, that the universe, whether observed or revealed, is fundamentally geometric, and that humanity's most sacred duty is to replicate that geometry in our most holy spaces. The Temple of Solomon, therefore, is more than a historical or religious footnote in our geometric map. It is a powerful testament to the enduring belief that number, shape, and ratio form the essential bridge between the earthly and the divine, an idea so potent that it shaped not just a single building, but centuries of symbolic thought and the very ideal of what it means to construct a sacred world. Now let us shift our gaze from temples reaching for the heavens to a civilization that turned its geometric genius inward, toward the very earth beneath its feet. In the vast floodplains of the Indus River, over 4,000 years ago, a society flourished whose greatest monuments were not pyramids or stone circles, but cities of breathtaking order and foresight. The ruins of Mohenjo-Daro and Harappa reveal a startling truth about ancient geometry. Here, the hidden blueprint was not primarily for communing with gods, but for harmonizing the lives of tens of thousands of people. This was geometry in the service of society itself. Imagine walking down a street in Mohenjo-Daro around 2500 BCE. You are not navigating a winding, organic pathway common to ancient settlements. Instead, you are moving through a meticulously planned urban grid. Major thoroughfares run straight north-south and east-west, intersecting at perfect right angles to create large city blocks. Smaller lanes branch off these main arteries, providing access to neighborhoods of standardized mud brick homes. This is not a happy accident of gradual growth. This is conscious, large-scale geometric planning on a level that would not be seen again in urban design until the rise of classical civilizations over a millennium later. The geometry here is one of profound practicality and egalitarian vision. Consider the bricks across hundreds of miles from Mohenjo-Daro in the south to Harappa in the north. The builders used baked bricks of a standardized ratio. The most common dimensions were in a perfect proportion of 4 to 2 to 1. This standardization meant that bricks from one city could fit seamlessly into construction in another, a testament to a unified cultural and technical vision. But the geometric genius goes far beyond the simple shape of a brick. Look beneath the streets. The Indus Valley people engineered one of the world's first comprehensive urban sanitation systems. Nearly every house had a bathing area and drains that connected to a network of covered sewers running beneath the main streets. These sewers were not just ditches. They were carefully constructed with bricks and mortar, designed with a precise gradient or slope to ensure a constant flow of wastewater away from the living areas and into collection pits or out beyond the city walls. Calculating and maintaining that consistent slope across an entire city, ensuring it worked by gravity alone, required an advanced, hands-on understanding of geometry and hydraulics. This was applied mathematics saving lives on a daily basis, preventing the spread of illness and creating a standard of public health that was extraordinary for its time. The architecture itself, while lacking the overt astronomical alignments of Stonehenge or the symbolic ratios of a pyramid, speaks of a different kind of sacredness. The concept of the sacred here may have been rooted in community, cleanliness, and collective well-being. The city featured large, imposing structures like the Great Bath at Mohenjo-Daro, a large, waterproofed public tank that likely served a ritual purification purpose, again highlighting the cultural importance of water and cleanliness. There were also large, pillared halls that might have been for communal gathering or administration, but notably, there are no colossal temples or palaces that dramatically overshadow the common houses. The urban plan suggests a society where geometric order served a somewhat egalitarian ideal, organizing space efficiently for all citizens rather than aggrandizing a single ruler or priestly class. This presents a fascinating counterpoint in our global investigation. In Egypt, geometry monumentalized the pharaoh's divine journey. In England, it tracked the cycles of the moon. In the Indus Valley, geometry built a functioning, healthy, and remarkably stable metropolis. It was the operating system for one of the world's first large-scale urban experiments. This civilization's mastery of right angles, standard units, and calculated gradients solved the immensely complex problems of density, sanitation, and transportation. Their hidden geometry was the framework for a social contract written in brick and mortar. It proves that the ancient impulse to impose mathematical order on the world was not solely for spiritual or celestial purposes. It could be profoundly, beautifully practical. The silent, grid-like streets of Mohenjo-Daro stand as a powerful reminder that the pinnacle of ancient engineering might not always point to the stars. Sometimes the most revolutionary geometry is the kind that simply and brilliantly helps a society live together in peace, health, and remarkable order. For centuries, the search for hidden geometry has relied on the sharp eyes and patient calculations of dedicated researchers, measuring stones under the sun and plotting lines on parchment. It has been a deeply human endeavor, limited by human scale and human bias. We see patterns we expect to see, and we might miss connections that are simply too vast, too numerous, or too mathematically obscure for our minds to hold at once. But what if we could partner with a new kind of intellect, one without preconceptions, capable of sifting through entire libraries of data in the time it takes to read this sentence? This is no longer science fiction. The next great leap in mapping the ancient world's blueprint is happening not in the desert with a theodolite, but in server rooms with lines of code. The future of this search belongs to artificial intelligence and machine learning. Imagine feeding a sophisticated algorithm every known coordinate of every standing stone, temple foundation, and pyramid apex from sites across the globe. Now imagine asking it a simple yet profound question. What patterns connect them? An AI does not get tired. It does not favor a pet theory. It treats every data point with equal cold curiosity. It can analyze thousands of variables simultaneously, not just alignments to solstice sunrises, but alignments to minor stars, to the peaks of distant mountains, to the courses of ancient rivers now dry. It can search for geometric shapes within urban plans that are not simple squares or circles, but complex polygons and spirals that our brains might dismiss as irregular. It can calculate probabilities with brutal objectivity, telling us definitively whether the alignment of three sites is statistically remarkable or something that could easily occur by random chance. This moves the entire field from the realm of compelling anecdotes into the rigorous world of data-driven discovery. one of the most exciting applications is in the simulation of ancient skies. For any given location on Earth, the night sky changes gradually over millennia due to a slow wobble in our planet's axis, a motion known as precession. Determining if a temple corridor was aligned to a specific star 3,000 years ago requires complex astronomical modeling. Today, researchers are employing AI to run what are called brute force analyses. They can program a system to take a site like the Temple of Karnak in Egypt and not just test it against one or two suspected stellar targets, but against the entire reconstructed ancient celestial sphere. The AI can simulate every single night for a century, checking to see if the rising or setting position of any bright star, planet, or constellation ever matched the temple's axis within a tiny margin of error. What might take a human astronomer years of painstaking work, the AI can accomplish in an afternoon, potentially revealing alignments we never thought to look for. But the potential goes even deeper than confirming single-site alignments. The grandest hope is that machine learning might identify a global signature, a common design language woven across continents. Could an algorithm detect that the proportions of Mayan temple platforms in Guatemala share a hidden mathematical relationship with the dimensions of burial mounds in Japan, a connection no scholar would ever think to compare? Might it find that a specific angle, say 19.5 degrees, appears in the orientation of structures in Peru, Egypt, and Cambodia more often than pure statistics would allow, hinting at a shared geodetic or astronomical principle? This is the promise of AI as a collaborative tool. It is not meant to replace the archaeologist or the historian, but to augment them. It can process the big data of antiquity, presenting human researchers with new, evidence-based hypotheses to investigate. It can silence fringe theories with hard numbers or, more thrillingly, validate unexpected connections that become the focus of entirely new research. We stand at the threshold of a new era in understanding our past. The silent stones have held their geometric secrets for millennia. Now we are developing the ears to finally listen to what they have been saying all along, not in a whisper, but in the vast, interconnected hum of data waiting to be decoded. All of this data and discovery can sometimes feel like a map drawn on a screen, a theoretical exercise divorced from the physical world. But the true power of this hidden geometry isn't locked in a database or a research paper. It's waiting for you out there in the light and the stone and the landscape. This journey doesn't have to end when the video does. In fact, the most rewarding part is just beginning, because this isn't just an academic puzzle, it's an experiential one. You don't need a degree in archaeology or a plane ticket to Egypt to start seeing the world through the eyes of an ancient architect. The principles we've been exploring are etched into the fabric of our own surroundings, often in plain sight, waiting for a curious observer to notice them. Start locally. Look up at the oldest building in your town or city, perhaps a courthouse, a library, or a place of worship from a century or two ago. Before you even step inside, stand before its facade. Notice the shape of the windows. Are they tall and narrow, wide and inviting? The proportions you're seeing weren't chosen at random. Many architects, especially from the Renaissance through the 19th century, consciously used ratios like the golden section to create a sense of harmony and balance that feels instinctively pleasing. Walk inside an old cathedral or a grand central station. Look up at the vaulted ceiling. Can you see the repeated arches, the symmetry radiating out from a central point? That is sacred geometry in action, designed to lift the gaze and, symbolically, the spirit. The next time you pass a classical building with a triangular pediment supported by columns, you're looking at a modern echo of the Parthenon, a design language that has traveled through millennia because its geometric foundation feels fundamentally right. Your smartphone, often seen as a symbol of our disconnected modern age, can actually be your best tool for reconnection. On the next clear evening, find an open space as the sun begins to set. Open a simple compass app on your phone, stand still and note where on the horizon the sun disappears. Is it due west or is it shifted slightly to the north or south? That shift tells you a story about the time of year, just as it did for the builders of Stonehenge or Machu Picchu. On the morning of a solstice, around June 21st or December 21st, make a point to watch the sunrise. Note its position along the horizon compared to other mornings. You are, in that moment, performing the same act of observation that was the cornerstone of ancient timekeeping and celestial mapping. You are participating in the oldest human science. If you have the opportunity to visit a known ancient site, large or small, go with a new set of intentions. Instead of just taking a photograph, take a quiet moment. Stand in the center of a stone circle, or at the base of a pyramid, or in the nave of a great cathedral. Feel the space around you. Is it designed to make you feel enclosed and protected, or small and awestruck? Listen, clap your hands once. Is there an echo, a reverberation? You might be standing in an intentional acoustic chamber, a place where geometry shapes sound. Use your body as a measuring tool. How many of your footsteps does it take to cross a plaza? Does the path you're on run straight for a long distance, revealing a preoccupation with linear precision? By engaging your senses, you move from being a passive tourist to an active investigator, feeling the intentions of the builders in a way no textbook can convey. This personal exploration creates a profound bridge between past and present. The sense of wonder that washes over you when a shaft of light perfectly illuminates a cathedral's altar at noon, or when you realize the local war memorial is aligned to true north, is not a modern invention. It is the very same spark of recognition and awe that motivated a priest astronomer in Chaco Canyon, a master mason at Chartres, or an Inca planner in the Andes. You are tapping into a continuous thread of human curiosity, the innate drive to find pattern, meaning, and harmony in our world. By becoming an observer, you are no longer just learning about history, you are conversing with it. You are adding your own point of data, your own moment of connection, to the vast and beautiful map we have been exploring together. After exploring sites from the Andes to Angkor, after measuring stones and mapping stars, we are left with one overarching question. Is it possible to draw all these threads together into a single, elegant theory? Could there be a master blueprint, a lost instruction manual from a primordial civilization that was faithfully followed by cultures separated by oceans and millennia? The romantic appeal of that idea is undeniable. It suggests a neat, clean answer, a unified field theory of ancient genius. Yet, when we look at the evidence with clear eyes, the reality appears both more complex and in many ways more fascinating. The world does not present us with a single, copied blueprint. Instead, it offers us a stunning array of variations on a set of profound themes. What we are seeing is not the replication of a specific plan, but the independent and convergent application of a shared cognitive toolkit. This toolkit was not a physical set of instruments, though those certainly existed. It was a collection of intellectual and spiritual priorities, a way of seeing and interacting with the world. The first tool in this kit was a deep, reverential observation of nature. Ancient peoples watched the unwavering cycles of the sun, moon, and stars. They studied the spiral of a seashell, the branching pattern of a tree, the repeating symmetry of a flower. They recognized in these patterns a language of efficiency, growth, and beauty. From this observation, they extracted mathematical constants like pi and phi, not as abstract equations in a textbook, but as living principles of a harmonious cosmos. The second tool was a powerful desire to bring that celestial and natural order down to earth. It was an act of world building, of creating a sacred microcosm. A temple was not just a building, it was a model of the universe. A pyramid was not just a tomb, it was a ladder between the earthly and the divine realms. The geometry provided the framework for this symbolic replication, ensuring that human creation resonated with the perceived structure of creation itself. The third component of this toolkit was a pragmatic, geodetic awareness. Whether through meticulous long-term observation or sophisticated surveying techniques we have yet to fully understand, these cultures learned to measure their world with astonishing accuracy. They learned to find true north, to level vast foundations, to plot points across immense landscapes. This skill allowed them to anchor their cosmic symbolism in physical reality, to align a pyramid with a star or a temple corridor with a solstice sunrise. The final and perhaps most crucial tool was the adaptation of all this knowledge to local conditions. This is where the glorious diversity springs to life. The same underlying impulse to harmonize with the cosmos produced the stark, monumental geometry of Giza on the Egyptian plateau, using abundant limestone. It produced the sinuous, mountain-hugging terraces of Machu Picchu, built from local granite in an earthquake-prone region. It produced the vast, flat grid of Mohenjo-Daro for social order in the Indus Valley, and the sprawling celestial mandala of Angkor Wat in the Cambodian jungle. The toolkit was universal, but the applications were brilliantly local, filtered through unique religious beliefs, social structures, and environmental challenges. Therefore, the hidden geometry we have been mapping is not the signature of a single teacher, but the syntax of a global architectural language. It is the grammatical rulebook that different cultures use to write their own unique stories in stone. The fundamental vocabulary of this language consists of the circle, the square, the triangle, and the spiral. The grammar is the relationship between these shapes, governed by harmonic ratios. And the poetry, the meaning, comes from how each culture used this grammar to express its relationship with the gods, the heavens, and the earth. Some, like the Romans, used it for a grammar of power and practical dominion. Others, like the Maya, used it for a grammar of cyclical time. The builders of Stonehenge used it for a grammar of celestial prediction. So, do we have a unified theory? In the sense of a single, secret source, the answer is likely no, and that makes the phenomenon more powerful. What we have is evidence of a unified human impulse. It is the impulse to find meaning through measurement, to seek connection through alignment, and to create legacy by embedding the timeless patterns of the universe into our most enduring works. This shared cognitive toolkit reveals something fundamental about the human mind in its ascent to civilization. When freed to contemplate the grand questions, separated cultures again and again turned to geometry as their medium of expression. They were all attempting to solve the same great puzzle, the puzzle of humanity's place in the vast, ordered, and beautiful cosmos. The fact that they arrived at such strikingly similar tools to build their answers is not a mystery of diffusion, but a testament to a profound and shared intelligence. We are not looking at the scattered pages of a single lost book. We are listening to a chorus of different voices, all singing the same majestic, mathematical hymn. Our journey mapping the hidden geometry behind ancient megastructures reveals more than forgotten math. It unveils a portrait of humanity's deepest aspirations. We have walked the grid of Mohenjo-Daro, traced the angles of Machu Picchu, and stood in the shadow of the Great Pyramid, not just as observers of architecture, but as readers of a profound and silent language. This exploration shows us that from the pyramids to the Parthenon, our ancestors used stone as far more than shelter or monument. They used it as a medium for conversation, a way to converse with the stars, to emulate the flawless perfection found in a nautilus shell or a sunflower, and to architecturally reach for the divine. In every precisely laid stone, in every alignment to a solstice sunrise, they were making a statement about order, meaning, and humanity's role within a vast, interconnected cosmos. This geometric code etched into the planet is their lasting legacy to us. It stands as a quiet but formidable challenge to our modern assumptions about progress and primitive capability. It is an open invitation written in the language of shape and proportion for us to look deeper, to question more, and to recognize a different kind of intelligence in our shared past. The philosopher Plato once taught that geometry will draw the soul toward truth. In a very real sense, that is exactly what these ancient builders were attempting. They were not merely constructing buildings, they were constructing truths, physical anchors for their understanding of reality. The circle was not just a shape, it was eternity. The square was not just a foundation, it was the stable earth. The upward thrust of a pyramid or a spire was the soul's ascent. By decoding the stones they left behind, we are not just learning about their trigonometry or their astronomy, we are learning something fundamental about the architecture of the human mind itself. We see a universal impulse to find pattern, to create harmony, and to leave a mark that speaks across centuries. This journey teaches us that our place in the universe has always been a question we have tried to answer not just with words, but with works, with immense, calculated beauty aimed at the heavens. If this exploration has reshaped your view of history, if you now look at an old cathedral or a local stone circle with a new sense of curiosity, we would love to hear your thoughts in the comments below. Share which site's hidden geometry resonated with you the most. For more journeys into the unknown, into the lost chapters and unsolved puzzles of our world, be sure to subscribe. And as you go about your days, remember this final thought. The past is not just a story in a book relegated to a chapter behind us. It is encoded in the very ground we walk on, in the alignments of our oldest streets, in the proportions of enduring buildings, and in the silent, waiting stones that still catch the dawn light on a solstice morning. The map is all around us. We just have to learn